Greetings, hello, welcome everyone. Welcome to DevChatter. And we start things off right with S&B's resub. Welcome everyone, welcome to DevChatter. As you can probably guess from the name label below me, my name is Brendan, and I am the host of this channel, which is DevChatter. And we are here this nice Saturday afternoon, or it might be morning or evening or something else, depending on where you are in the world. But either way, welcome to the stream. We are going to be doing some fun coding together today. The code that we have been working on lately is in JavaScript, though our channel does do a reasonable amount of C# as well. We mostly do C#, and probably our second language is JavaScript. We occasionally do Python on here as well. If you are new, feel free to ask questions. We're a very welcoming community, so the people in the chat or I or any guests that I have here on the stream will be glad to answer questions for you. You won't get any kind of snippy response unless unless you phrased your question that way. The community is very open. We are more than just a live stream. We also have a Discord that has a bunch of people that chat outside of the stream as well. So if you are interested in chatting with me or anyone else, that's how you talk with us, in the chat or in Discord. Obviously, Discord's not going to be all that lively while the stream is live. But welcome everyone. Glad to see you are all here. I know I saw Zufo, Mr. Shoji, S&B, and CMJ Chris Jones is here, and probably some other people lurking in the background. And also there's that guy Royse is here. Yeah, up there. Hi Guy, how's it going? I'm gonna go ahead and unmute you, and I will let you introduce yourself. Go ahead.
See, he says hi, I say hi back, and then he's like, oh, now I'm gonna unmute you.
Well, that's not very nice.
I see how it is. How it is. So yeah, my name's Guy Royse, and I'm joining Brendan here on the stream today. We've been doing, he talked about writing inefficient data structures in JavaScript. Last time we were on stream together, we did a linked list. We almost got it finished. We just had a couple of refactors we wanted to do, and we thought, that's kind of a lousy way to start a stream. Let's refactor something and start something new. So we're just going to start something new and live with the slightly less clean code, and just refactor it off stream maybe at some point. And then today we're going to build a hash table. So, or a dictionary. I guess if there's a lot of C-sharpers on the stream, then you would think of those as, it's dictionaries in C#, right? Brendan?
What? Sorry, what was that? we do dictionaries in C#?
They're called dictionaries in C#,
yeah,
right?
we call them dictionaries.
Yeah.
Though we still have some other things that have hash in the name. But yes, generally when we're talking about those, we would call them dictionaries in C#.
So we're going to create an implementation of a dictionary in JavaScript, which should be fun. And obviously, you're totally welcome to try this at home, but don't try this in production.
The intention with doing these kinds of things is to understand how the data structure is working, not to implement a version of it that you actually intend to use. That being said, you can, there are plenty of programmers that do build their own data structures that they use for very specific reasons and very specific cases. But keep in mind that the person that does that, it's usually not their first time building one of those data structures either, and they probably have a very good reason why they need their own, as opposed to the one that you find in some standard library.
Yeah.
That or the person's just crazy. One or the other. Yeah.
I actually worked on a project early in my career. Early, it was the late 90s. And
so you were working 30 or 40 years into your career by that point?
Yeah, exactly. And we were working on solving some Y2K, solving some Y2K issues. And a lot of the solutions to Y2K issues was, well, we should just write that new version that we were talking about writing anyhow. And so we were writing the new version they were talking about writing anyhow. And we had someone on the team that was just a super performance bithead kind of guy. And he decided to go in and rewrite fundamental things in C and C++ that have been in production for, even then, decades. And he wrote A to I. He wrote an implementation of A to I that was like 3% faster. And he thought we should all convert to it.
Because there's no way there's anything else wrong with it either.
Right.
Yes.
So don't be that guy.
Yep. We all know that guy, and the sad part is when that guy that you know that does that then goes and actually works on the language and builds like the new version of the thing in said language, then it's like, okay, that version that's in there, yeah, that one you use. Like, that's the version you use, because that one's going to get maintained. That one's going to get updated. The whole community is going to rally around that and be like, oh, we found out that it was, 3% more efficient, but we also needed to fix these other 20 things about it. And it takes, like, a whole industry of developers to realize that that's what was missed.
Yeah.
So,
yeah. Sometimes it's okay to create Lodash, right?
Yeah.
But don't create Lodash for your own application.
Exactly.
Yeah.
Yep. Excellent. Well, so let's talk about this project. So in this, we actually have a GitHub project. This is out on Guy's GitHub account. So if you go to github.com/GuyRoyse/data structures with a dash in there, which I will link in the chat, you can actually see the project that we are working from. We are just working straight on the master branch because, well, this is just a stream, it's throwaway code, so we're more focused on the code here than we are in doing all the gitting correctly for this because, well, it's going to be straight one-person development into this thing, following along with a stream, so there won't be a lot of, like, rework, backing out, or switching branches and things like that to change tasks, as we aren't going to get someone that suddenly tells us, hey, there's a new priority, because that's us.
Yeah, we're not going to have to type git merge master. That's not going to happen.
Yeah. So. Okay.
So incidentally, a fun fact: I was on a project team one time, and whenever we did git merge master, we played Master of Puppets by Metallica.
I guess you could.
Yeah, it was fun.
So the project that we've built is obviously in Node and JavaScript, and we were building it with TDD. So we have this nice spec here that is doing all the tests for the linked list that we created. We did a doubly linked list, and we have our test passing, so things like when we created, it is empty, it has size of 0, and it's going to return back null if you try to grab the first item. And when you add an item, it's not empty. So this is the basic structure of what we were setting up so far. And now we are going to do the same kind of TDD approach for a hash table.
Yeah. Do you want to take a lead on creating the spec file this time? I did it last stream.
Take a lead. You mean do you
want to drive
this?
Yeah. Copy and paste.
I can copy and paste if you want me to copy and paste.
Yeah.
That's fine. I am capable of copy pasta. So what are we calling it? So we doing hash table spec?
Yeah, we'll call it. It'd be hash-table-spec.js.
Yep. Cool. Good. We're in agreement there. And then I need to close that brace, and I think I need to close another one too. Yes,
you need
I do.
you need and then you need to close parent, and then
I'm closing the context and I'm closing the describe there, right?
Right, but they need parentheses after them as well.
You're right. And then that is it. Okay.
Yeah, and then
so I don't want to include the linked list. We're going to make something else. Since we're not exporting that yet. So this will be hash table. Hash table. What's chat yelling at me? Hey, Lumen, welcome to the stream. Yes, we're going to TDD this thing. And good evening, Stoolpenner. Welcome. So that's what we're going to expect to have. Hash table, hash table. The subject is fine when created. So we'll create a new instance of it.
Yep.
And then we do expect it to be empty, which I thought was a fantastic way to start it, because it's going to have that same type of thing. It is a collection. It has a concept of being empty. So that, unless I missed something, is a test that will fail horribly because the stuff doesn't exist.
Well, let's run our test and see what happens.
So we're going to go ahead and npm test. Hey, Katrina. Hey, S&B. Stool Punter. Lumen. Welcome, everyone. Test failed.
Is it not a constructor? This is exactly what we expect to see. So let's go ahead and...
Correct, because we have no type.
Are you following me now?
Let me... There we go.
Okay, so I've gone in here in the data structures. I'm going to expose a hash table. Require... / data structures. Did I spell that right?
Yep, looks right.
Hash dash table. No.js there. And then in here...
I thought it was optional. Is it not optional there? I can't remember.
I don't know if it's optional or not required, but the other one doesn't have it. So when in Rome...
Okay, yep, fair.
When in Rome...
So that basically tells everything that if you include the data structures module, then it's gonna, we can require in these two objects to it as well. So someone can include data structures instead of individually including each data structure.
Right.
Yep. And I should still be pinned to you.
Okay. And then there's our linked list, and I'm just gonna clone and
copy pasta.
I'm gonna clone and modify copy pasta class.
Copy pasta. Yum.
I should share everyone what I had for lunch today.
They really don't want to know, Guy.
Yeah.
But now they're going to want to know because we said they won't want to know.
I had the most bachelor thing I've ever had in a long time. Mind you, I've been married for 25 years, so I don't really eat like a bachelor anymore. But I had leftover rice, leftover steakums, and leftover salsa con queso. And I just mixed it all together and microwaved them. It's delicious, and my heart is not thanking me. Okay, let's see if our error changes. It should.
So subject.empty is not a function. That looks perfect. So now we need to have that empty function, which you can just make an empty function if you want.
Yep. True.
True, yep. There you go.
Huzzah.
Hey, that's passing. And the other neat thing about that one is that that also means that saving was working for you. So hopefully that maintains for the rest of the stream, and we don't have that problem like we did 2 weeks ago.
So is empty. What do we want after is empty?
Well, do we want to continue and make is empty actually work right now, or do we want to add something else? Because last time I think what we did was we said once you added an item, then is empty would be false.
Right. I think that's a good course. We did a size last time too, but I don't know that. Did we do a size last time?
We did do a size. Yep.
Yeah,
we had
but
a size on the linked list.
I don't know if we want to do that on a hash table or not. Although we also said I don't know if we want to do that on the linked list or not.
I think it's valuable to have, but you're right; it can get complicated in some things.
Yeah.
We could skip it if you want.
I think we should add something and see that it's not empty. So that feels like a good place to start.
Yep, I agree. Let's go ahead to the spec and
I'll go ahead and write a test.
Yeah, let's. Are you just going to context us again?
Yeah, I am. Okay. I was typing when because I have this old thing I used to do in Jasmine. That doesn't work in Mocha.
We all get used to whatever programming frameworks and tools we're used to. It's what kills me with JavaScript. Like, I used to write JavaScript a long time ago. C# and JavaScript are now very difficult for me to switch between because they're just close enough that the object initialization syntax is so similar, and it's like the only difference is, do you use equals signs or do you use a colon?
Yeah.
It's like, great. Yep, when an item is added to the hash, so this will be our function that does a subject dot. Are we gonna just say dot add or something? What do you think for that?
I think put and get would be good.
Okay, yeah, we can put. You gotta love
or maybe
IntelliSense.
put and fetch, since Git tends to be a keyword in a lot of languages.
Sure, yeah, that's fine.
So put, and then we need to give it a key. What are we going to store?
What did we do last time for our examples?
We used
We used D&D
races.
classes and races.
Classes and races. I think so.
Okay, so we need something equally nerdy.
We used. It had barbarian, beard. Then we used races as well, and baker.
Yeah, I know we used races as well. What's the So I guess we'll use we'll switch over to a digital form, and we'll use video game characters then instead of something like that. So pick a video game character.
Okay, so what's our key? What's our value?
Master Chief.
Okay, that's our key. Or like this.
I was gonna say master. Yeah, yep. Like that's what I was thinking.
Okay.
So then, because I was like, then we can use like
video characters.
Yeah, video game characters that have like two words to make their name. Can be our.
But I only play RimWorld.
You could use a RimWorld character.
Randy Random, yeah.
Yeah, or sure, yeah, Randy Random. I forget. Is one of them Cassandra or something?
Yeah, it is something Cassandra.
Yeah.
It's the default, but I can't remember what it's.
Yes, I don't know if you saw, but there's a new DLC for RimWorld that just came out. Like.
Yeah, I saw that.
Weeks ago. Yes, we play RimWorld. It is a fantastic game. It was one of my favorite games, and I, as a horrible friend, had to tell Guy all about it at a conference many years ago. And it's one of those ones that it's like, once you hear about like the extent to which some of these games let you go, you're like, okay, that would be really fun. Okay, so we don't have a put function. So
I think RimWorld's kind of like Dwarf Fortress in space, but easier.
Yes, exactly. It's like it's a simpler version of Dwarf Fortress.
Yeah.
Which in many ways is good because Dwarf Fortress is often way too much to deal with.
Commander Keen. That's totally coming next. I played a lot of Commander Keen in college.
Okay. Whoops. Okay, so we said we're going to have a put, and put is going to take in key and value, right? Which we don't really care about.
Yep.
And then what's it called in here? Constructor?
Yeah, constructor, parent, curly brace.
And I want to say this dot is empty.
That won't work.
Just kidding. For now, since we don't actually have to hash them yet. Actually, yeah, no.
Yeah, test driving this is going to be interesting because there are some internal behavior that
we're going to need to force the internal behavior on some of these things. But for now, I am going to start us with the cheater approach.
Yeah, I think that's fine for where we're at.
Yeah, exactly. Because I do think if we're really going to test drive this, then has item equals true.
Yeah.
And I don't think I did anything crazy, but we're about to find out.
We can actually do this because JavaScript.
Yeah, I don't technically need them, but I see no reason not to have them there.
Yeah, that's fair.
I'm gonna put them back because those can be there. Like I'm acknowledging that we absolutely need them. Oh yeah, I missed an empty line there. Okay, so it's no longer empty now. How do we? So I need to force that we can actually put this somewhere. So do we want to try getting it by key? Which still doesn't force that we put it anywhere. Not really.
Well, so you're saying we can get the thing?
Yeah.
Since we put it there?
Yes.
When an item is added to the hash, it is no longer empty, and it can be retrieved.
Yes, exactly.
I think that's a good second test, or third test. That at least gives us some tracer bullets to figure out where, it creates all the scaffolding code we'll need to do things later. I'll go ahead and fix that for you.
Did I capital I?
No, you did a if instead of an it.
Oh, well, yeah, that'd be bad too.
Yeah. This is actually one of those things you can't do when you're physically pairing together in person.
The funny thing is, I actually recommend that people sit next to each other with laptops and do this.
Yeah, because you can actually edit the code at the same time.
Yes.
And catch like that.
Precisely. Though the funny thing is, many years ago, do you remember the Surface table that Microsoft built that was designed like... They built, like, it was a whole coffee table that was like the Surface table. It's the original thing called a Surface. They built that thing, and it had multiple cursor inputs in the same thing, and because they were like, oh yeah, multiple people might need to type at the same time, and so I was talking to them. I'm like, can you get that into like Windows? Like, can you build in the concept that I want multiple keyboards in Windows, please, guys? Because I was doing pair programming back in, like, 09 or whatever that was, and I was like, guys, please, like, we need this yesterday. So what did we said? Fetch?
Yeah, we decided not to do get because it's a keyword, even though you can't actually get away with it.
What is it? Was it to be equal?
I'll go look real quick.
Yeah, if you want to check our spec.
To equal. Yeah.
To equal.
It's one of those things where it's always subtly different in every little test framework.
Yes, exactly. And then this will be Chief, and then this is going to be Master.
Master. Get merge master. Yes.
Fetch. So when you fetch Master, you get back Chief. Okay, and that should fail for the right reason.
Fetch is not a function.
It is not.
Okay, we don't need linked list. We need go into hash table.
I need it. Anchor to you. There we go.
Okay, and we can call fetch key return master. Now, obviously, that is worthy of a refactor.
You meant Chief.
Yeah.
Yeah.
I was focused on Metallica, not Halo.
Although the funny thing is that Master is actually a better thing to put in there first to make sure that it can fail for the right reason still.
Yeah, so it worked out.
Yeah. Okay, so that is definitely passing, although for a really terrible reason. Let's force ourselves to actually write this. Do we want to do the next context of a second item, or...
I actually was thinking that we might want to do the context of when it's empty and you try and get something, there's nothing to be gotten.
Oh, yeah, let's do that. Yeah, that works. Because then that'll force us to save the item.
Yeah.
Not correctly, mind you, but just the single item would have to get saved.
It has nothing to be retrieved. Trying to make a sentence. There's a thing in Visual Studio Code where it's giving me this help that is just like totally in the way.
Yeah, it's getting me on that too.
I've been trying to figure out because it hides my test name. It's just kind of annoying. And what do we want to fetch? Probably not master.
It could be anything.
Actually, let's do master because...
definitely confirms that it's wrong.
Yeah. So expect...
Yep.
Master...
to be null?
To be null. Yeah, I think null's a good response. Well, that's better than undefined.
That is correct, Pudding. I am pair programming with Hagrid.
Yep. You're a wizard, Brendan.
Yeah, we are. What are you talking about? We're both wizards, man. All right, so you got that test failing for me for the right reason. So let's hop on over to the hash table.
Okay.
And so instead of this, let me just put in item for now. So I'll just save the item, and we'll say return this dot item equals null. I remembered to triple it.
Yay!
I'm getting my I'm every time I switch to JavaScript, I have to start thinking like, yes, this is JavaScript. I need to switch to JavaScript. So value, and then return this dot item, right?
Yeah.
And then that is the super fake way of making this pass, I think.
Yeah, I think so.
Unless I messed it up. At which point, if I messed it up, the tests are going to tell me. So, hey, green. Excellent.
Yay.
So, super cheating way still. I think that works out pretty well. So, nothing to be retrieved. It was empty, so we're unable to retrieve an item. It comes back as null. When we add an item, it can come back. I think we need to context within this context and say when we add another item.
Yes.
So I'm going to say context, and then this should be, what did we say? When, so I'm going to say when a second item is added to the hash.
Or we could say when another.
Sure. Did we say hash? Yeah, okay.
Yeah. Actually, this is going to be my stream of fun facts. The original Old English word for second was oter. So other actually comes from the word for second. So you had
that makes sense.
And other.
Also, Digital Drummer, congratulations on the Grenadon. Welcome to the 12 Months Club. Things are going well, Pudding, and welcome everyone. Glad to see so many friendly faces in the stream today.
Yeah.
Okay, so we're going to want another before each. So the last one we did was, let me clear this out of the way just so I can see a little bit more. So before each, we're going to say function, and we want to say subject.put, and we need our next video game character, who of course is Mario.
Mario? No, it's Commander Keen.
No, it's Mario. You can add Commander Keen as the third guy.
Okay.
Don't you remember that terrible Super Mario Brothers movie? Please tell me you saw that.
Well, I mean, I did. It entered my eyeballs. That might be a better way to say it.
Can retrieve when an item is the it can retrieve the. Do we want to say the second item? Actually, I'm going to say the first item because I think that's the one that's going to fail.
Well, we want to see that it can retrieve both items.
But I'll start with this test because I think this is the one that's going to fail first.
Yeah, but it can retrieve both items is kind of not that great of a test.
Yeah, it's not a bad. Like the first item it can retrieve the second item. I think makes sense, right?
Yeah.
Okay. So let's say expect subject not fetch not get. We're saying master, so trying to get the first item. Expect that to equal chief. And I think that is the test that is going to fail.
Expected Mario?
Wait, it should have expected chief and gotten Mario. Yeah, expected Mario to equal chief. Yep, that looks right. That's failing for the right reason. Let me pin to you.
Well, hang on. Sorry, I was distracted because my chat stopped working, and so I was trying to figure out why.
Oh, I don't know. Refresh it.
I tried that; it didn't work, and so I wasn't paying as close of attention as the to
Oh,
the
okay.
test.
Well, either way, so we put in Mario, so that one happens to
Yeah,
have the same key and value, which I also think is a great test.
yeah.
That bit of test data to have in there, and then we try to retrieve master, or we fetch master expecting to get chief, and we got back Mario because I came in and overwrote the value instead of adding.
Right, right. Got it. I was trying to parse why this was failing.
Yep.
And then I'm like, okay, yeah, I understand why it's failing.
It is failing
Okay.
because I did not actually make a collection.
Okay, so I'm going to do, I think what I'm going to do is I'm going to go ahead and use a JavaScript object for the hash, which is highlighting why test driving this kind of thing can be difficult, because but I want to see where that takes us, because obviously if we just create a wrapper around a JavaScript object, that's kind of silly, right? But that's even more sillier than what we're currently doing. But I want to kind of say, okay, now we're going to need to test. We're going to break this hash table is going to have to be broken up into some internals. And how do we test those internals?
Yep.
You know, and so I feel like doing what I'm going to do next will take us to that path. Does that make sense?
Yep. I think so too.
Okay, so we're going to say this dot, oh, God, what do I want to call this table? Data. That's a meaningful one.
That's not the worst name for it.
I mean, given what we're doing, it's actually a reasonable name.
Yeah. Stuff. Thanks,
yeah.
S&B. Yeah, stuff.
Yeah. Oh, if I make it an object, then all of a sudden is empty gets hard. We'll ignore that for now.
That might force us to keep track of size or something.
Yeah. That we'll do that.
So the funny thing is, people were joking about that, but I actually do. When I'm writing like real code for my clients, I will put in a name like does something, because I'm like, I don't want to think about what I'm going to name this yet. Like, currently my brain has me tracking like what I'm doing, not what I'm calling this. And once it exists, I can usually name it.
Yeah. So I want to get the value out and then say return value is undefined. If I can spell the word return right.
Yeah.
If it's undefined, then return null. Otherwise, return value.
Yep, that makes total sense. Yep. I agree completely. I'm on board.
Let's see what the tests look like so far. Expected null to equal chief.
Did we insert them correctly? This you didn't say data when you fetched. You just said this key. Should be this data key.
It's this data key, yeah.
Yep.
There we go. This is exactly the kind of thing I was hoping to find by doing that. Now they're still failing because
empty is not right.
Right, empty is returning.
Empty should.
It's actually always returning true.
Yes, because we don't set that value anymore. But how do we make that one work?
Keys. I mean, you could do object.keys data. That is not object.keys data. Thanks for helping out, Visual Studio Code. Size. This is awful. I'm a terrible person.
That's horrible.
Yeah, that's it'll pass. I think
that will pass. Yes.
This,
yeah, yep. Classes in JavaScript, we gotta this all the things.
I think that, well, then we don't need that anymore. But that's actually not that far off from what we're ultimately going to have to do to make when we start doing actual hashing to make it work.
Yeah, something like that.
Because we're going to have to go either that or we're going to keep a counter of adding.
Out of curiosity, do you have a hashing function handy? Or are we actually going to have to go do that?
In the package JSON, I brought in murmur hash.
Oh, yeah. We did that at the beginning, before the last one, didn't we?
Yeah. Now, I don't remember what the syntax of the murmur hash is.
Neither do I. Luckily, I know of a tool. It's called Google. And what you can do is you can actually look for things that other people have put on the internet.
Yeah. Well, I've used this in other code, so... I think you say murmur hash.v3 and then some input. And that looks like it's all it requires. But we need to feed a seed into it too. So I'm going to go ahead and actually bring up the code on my side to do that. I should write a test. Actually, that's what I need to do.
Yep, let's get a failing test that'll force us to do something.
I think I almost want to write size.
You want to do the size one?
Well, because it'll force us to create a counter. So that is empty.
Oh, do you mean to actually? So yeah, because we probably will just do a counter, won't we?
Yeah,
we don't have the ability to remove. What's that?
We don't want to walk the entire object thing every single time we want to get the size. We can just keep track of that instead and be more efficient for our inefficient data structure.
even though it's inefficient, that's too inefficient.
Yeah, I mean, even I have standards. Yeah. So I'm gonna do that actually.
Pickled, to answer your question, we are doing this for a combination of fun, entertainment, education. What do you want to? That's about it. No other reason to do these than it's kind of interesting to do it, and also kind of see how you can make them and see how you test drive and other stuff. It's yeah. Actually, Guy has a whole list of them. He checks them twice.
I'm making a list. There we go. That will force us to create a size function. Baby steps,
yes,
right?
he has a doubly linked list. That's why it gets checked twice. Once each direction.
Oh, very nice. Very nice. Who said that?
That was S&B. That was a good one.
Yeah,
he's got about 9 months
right
to.
Now, I'd give you inspiration token.
This one is a hash table. Yeah, we're okay. So we expect size to equal 0. We don't have a size function, but I will go ahead and make one. So we'll put it right after is empty.
That feels like a good place to put it.
Yeah, I thought so. Return. Did you only do the 0 case right now?
Yes, I did. One test at a time. Being a bit of a purist, I know.
All right. So that seems to pass. Let me go make the next one. When an item. All right. It can be retrieved. Has a size of 1. Okay. Now that should be good. There we go. Test is bombing. Let me pin to you again.
Okay. So we are bombing. Or we're passing, right? Oh, sorry. I was looking up. I was cheating.
Yeah, we need to make size equal 1 for this one.
Okay.
Very good, Guy. Very good. So we're doing this in like the. Oh yeah, we don't have a size to store yet. So you actually have. So you did have to store it. Haha.
Ha.
See, you had to do slightly more work than you thought.
I was trying to be extra uber lazy. Oh, it's because it's called size already.
Ooh, yeah.
Actually, I kind of want to do that.
You can do that if you want. I'm okay with it.
I'm okay with it too.
Yeah, I don't mind that. Okay, Why don't you give me a failing test by keeping track of the second one?
Okay.
Has a size of 2.
Dos.
Alright, now I actually have to go do a thing with this.
And then you're just gonna go size plus plus, right?
Wait, what? How did that pass? Did this not save? You didn't save.
Did I not save?
I saved now. There, now it's failing.
Okay.
The test didn't fail, and I was like, wait a minute. You didn't do plus plus, did you?
Yeah.
Okay, so... I think that's all I have to do. We didn't do anything else with it, did we? We just return it, we set it to that. Yeah, that should be it.
Yeah.
There is a shorter way, but this is the right answer. We're at the right answer. So part of the reason for the super simple step at a time is to make sure that I have a bit of insight. Let me pause for a second. I have a bit of insight for you. I know that none of you have ever experienced this before, and you haven't realized this in your time in the industry, but developers like to overcomplicate their solutions sometimes and build a bit more code than we need. I know it's not a... Yeah, I'm just kidding. We overcomplicate things. It's one of the reasons why you try to occasionally have developers slow it down a little bit and take a step back. Yeah. Thanks, Boxy Baby. Yeah, job security.
So I went ahead and
VS Code Live Share? Weird corruption issues. No. I've been using it since it was like a private pre-release thing, because I was able to get it for doing my live streams, but no, I haven't had much trouble with it. Occasionally there's weirdness and we disconnect and don't use it, but a lot of times VS Code and Live Share work well for me, so use it when it can. Slow it down with a sleep command. Yes, exactly. You put in some thread.sleeps. That's called job security. Okay, so I need to give you a failing test.
So I have a thought.
What? Oh, yeah. Yes, thought?
Treat it kindly. It's alone and in a strange place. I think we need to do delete.
Okay.
Now, when we're done, we will have wrapped up objects in JavaScript. But
yes. So I'm thinking do it as a context inside of the first item.
Yeah, I think so.
So that we can get back to empty as the first step.
Yeah, so we delete it, then we say, okay, now that we've deleted it, we can't retrieve it. It's empty and size is 0.
Yeah, that's what I'm thinking. So we're going to say context.
There's a little part of me that wants to write all those tests at once. But I'm not going to indulge it.
When an item is deleted, removed. Function before each. It's not a this, right? It's just a before each.
Correct.
Is this just a function?
Yeah, just takes a function.
We're gonna say
this step before each apparently works because we were doing it in the
Mario, we did it somewhere else.
I just fixed it.
What do you think? Remove?
Yeah, because delete's a keyword.
Yeah, that's what I was thinking. Master is the one that we remove.
Yeah.
And then we say it should be empty.
Yeah, it is empty.
It is empty is what we called. Okay, it is empty. Function.
Actually, I'm going to go ahead and copy these down here and just pen them.
Okay. Expect that subject dot is empty to be true.
Okay. Yeah.
I forget, what's the exit ones? Oh, those are the ignored ones, yeah.
Yeah,
yeah
it pens them so that they don't run.
Yep.
It was just a way, I just, because it's a copy of the previous test, so.
Yep, exactly. No, I think it's good to pull those down here. So remove is not a function. Makes total sense.
Yeah, so let's go ahead and remove, remove this. I thought of something I could do that would totally be a pain in the butt. And I think I might do it. Okay, that fails for expected reasons. So we're just checking is empty. Oh, we missed a refactor, by the way.
Which refactor did we miss?
The is empty should just say check size.
Oh, yes.
That was part of the point of doing that. Because I was going to say, when calling remove key, the easiest way to solve that problem would be to say this dot size equals 0.
Yeah, that would be a quick way to do that.
Except
and I will let you refactor that all in one go if you want, and switch that to just check size equals 0.
Like that. At 46 passing, 2 pending. And this is actually why we didn't want to write all 3 of those tests at once.
Yes. So this test is then going to fail because all we did was size. If you do... So, yeah, size is going to pass suddenly.
This one will pass. I'm going to go ahead and uncomment it just for that reason.
Okay, go for it. Yep.
Or unpend it. Are you okay with that?
Yep, I'm good with that. It didn't save for you, though.
Of course.
So I will run it. There it goes. Now this one is going to fail.
Yes. I hit Command S 7 times. It should have saved by now.
It did this time.
Okay.
There we go. So it expected chief to be null. So it didn't come back with null. It came back with chief, which means a remove didn't actually remove anything. Guy, what are you doing?
The easiest way to solve this would be say this dot underscore data equals object.
No, Guy.
Well, I mean,
I guess you're right. I could go do this, and then that is technically...
Well, because that's how you would do like a flush, right?
Yes, it is, but we didn't write that. We wrote remove. But yeah, this is going to make it pass. So you're right, it does. Let's go do the other thing.
Yeah, I know, it's a little tedious. Did you save?
Yep, it's saved and it's running and passing, so I'm going to go give you the test that fails now. Man, I'm stuck writing all the context this time, aren't I?
Yeah, well, sometimes you're the windshield and sometimes you're the bug. To quote a country song.
Hang on, let me get rid of this just so I can get a little bit more space. Alright, so we're saying, is this also going to be when an item is removed?
We could say when that item is removed, if that helps.
When what?
Because it's in the context of when another item is added, and then when that item is removed.
Yeah.
That's how I would say it if I was speaking.
When that item is removed. Yeah, no, it makes sense. We might need to adjust our names at some point, but it's fine for now. So before each, we're going to say function.
I think this is the last test we're going to be writing for the outer hash table.
What's that?
I think this is the last context for the hash table itself we'll be writing.
Before we just start doing a whole bunch of changing of the structure to where we actually have to start confirming that we're actually hashing.
Yeah, because all we need to do is be able to do is add, fetch, delete, get a size, and ask if it's empty. And this will test that.
So we're going to remove Mario and say it has a size of 1. Would be a good check.
Yeah. Yeah.
This one's going to pass, I think, actually. This is going to pass.
No, it's not, because we set size to 0.
Did we? You didn't
Yeah,
subtract? Sure. You're right.
Yeah.
Good job. We get to you get saved again from having to do any work.
Doing anything hard.
Congratulations, guy. You still have to do no work. None.
Subject
wow, Doc. Wow.
Yeah. Hey, hang on. Very nice. Very nice.
Yeah, that was good. Yeah. All right, so this is failing. I think you can make this pass, guy. I believe in you.
You believe?
Your abilities to do this one.
Okay.
Hang on while you change those into... Yeah.
There we go.
Wow, so much work. So much work. Oh, man. Oh, can you... wow, see? Oh, guy, that was beautiful
Chief,
coding.
I'm the master coder.
Yes, yeah. Master coder up there.
Yeah. Could be a master builder, I suppose. And then we probably still need to be able to retrieve the first item, but not the second item.
Yes, we expect to still retrieve the first item. Yep, like that.
Did we, when another item is added, we never tested to see if we could actually pull Mario out, did we?
That's, yeah, go ahead and put that one in there.
Yeah. Let me get this one here first.
Yeah, that's fine.
Retrieve the first item.
Yep, can still retrieve it, and that looks right. So.
And now let's go up here and put that missing test in.
Yep. And I would get rid of the still.
Yeah.
When you do that. Yep. Yeah. There you go. And then this should
Mario,
be Mario and Mario. There we go. That is saved.
Okay, run the test.
Expected null to equal chief.
That is exactly the error I would expect.
And also I wanted to scroll and confirm that we have 50 passing and 1 failing. I just wanted to make sure that it wasn't 2 failing tests. But yes, this is the error. This is the one that we expect to have failing. So we lost this. Oh, man. Oh, who did that? What? No, that was a joke. Are you not following me? The joke.
Go.
Yeah, the joke
I was trying to follow you. I wasn't following you, actually.
Okay. I was like, who did this thing where all they did was... So...
What the hell, Dev? What the hell, Brun? Yeah.
What crazy dev did this? I
just threw up a little bit. I'm gonna refactor this.
Feel free, yeah, go ahead. Oh yeah, you can do that if you want. That should also still work.
Yeah, well, it's the difference between in JavaScript. I don't know if you know this or not. You probably do, but for folks on the stream, in JavaScript, if you set a value in an object to undefined, it's in the object as undefined. But if you delete it, it's removed.
Mm-hmm.
Now, in both cases, it's going to return undefined, but in the second case, the keys are correct. So, because undefined in JavaScript is undefined because it's undefined, not because it's defined as undefined. So.
Yes. All right. So the.
Then
we need to actually build a real structure now.
What's that?
We need to build a real structure now, right?
Yeah, we got one more. We should probably test to make sure we can't retrieve the second item.
Oh yes, that's a good point. The test that'll still be working. Cannot retrieve the second item.
Yeah, just
removed item.
For a thorough suite.
What's that?
Just for a thorough test suite.
Yep. Did we say undefined on this?
We didn't.
No.
It will return null.
Yeah, null. That's what we said. To be null. That's what it was, right?
Yep.
Cannot retrieve the removed item. Yep. And I think that passes already. It does.
Yep. Got a full deck of tests.
Okay.
There's 52.
So
of
let's read through them.
Yeah.
So we said when created it is empty, has nothing to be retrieved, has a size of 0. When an item is added to the hash, it is no longer empty. It can be retrieved. It has a size of 1. When another item is added, it can retrieve the first item, can retrieve the second item, has a size of 2. When that item is removed, it has a size of 1. You can still retrieve the first item. You cannot retrieve the second item. When an item is removed, it from the context of it, only having one item, it is empty. It has nothing to be retrieved and has a size of 0. That makes sense to me.
Yeah. It's a very thorough test suite.
Oh yeah, no, I think that's good.
I think it describes what hash tables should do. So we're done.
As far as a user's like the user of it.
Yeah.
Yes.
So great. Now how do we want to make this actually a hash table? Because we're going to need we need an array.
Yep, we need to change data into an array of some kind, and we need a hashing function to determine where the key gets assigned in that array.
Right, and then that it needs to be an array of buckets. It actually needs to be an array of linked lists of buckets, because each slot in the hash table
can have more than one item.
It can have more than one item, and the linked list needs to contain the key so that we know if we have a hash collision, well, an index collision really, then we know which one we're retrieving. And I don't know that we want to assume our hash function is going to return unique numbers, although it probably will. So I'm inclined to want to store the string key as opposed to the result of the hash. But I'm also inclined to want to return that because we might want to write a function to get all the key names at some point. That could be useful.
I think that makes sense. Also, keep in mind that right now, because we are removing based on the key itself, if there is a collision in the hash, we need to make sure that we get the correct one.
Right. Yeah, and so we need the key for that reason as well. So I think I guess where I'm going is I think the bucket needs the key name, and it needs the value. That's probably all it needs. Putting the actual hash in there might be useful, but I don't think it will be actually.
No, I don't think we need the hash because that's how we're going to determine where it is in the array, and that'll be duplicate for anything in the same spot.
Now, in theory, as we fill this hash table up, the array will get kind of full, and you'll start having more and more collisions, and so you'll need to resize it. I don't know that we'll get to that. It will still work with a smaller array.
You just end up with loss of efficiency because your linked list gets longer.
And so maybe that's okay because we are building inefficient data structures.
Yeah, let's do that for now, and then we can decide. Like that's a task of the future, making things grow.
Yeah. So do we want to start with where do we want to start here? Do we want to test maybe a bucket? That's not terribly interesting.
The bucket's the bucket doesn't really need to be anything. The bucket's basically just we could just use a JavaScript object for that.
Yeah.
Like an object that has a key and a value as its named properties, basically.
Yeah. And so and the linked list is already created.
Yes. So we need to make a linked list at any point in the array. So we need to turn data into an array.
Actually, what we need to do is we need to commit and push this up to GitHub before we do any of this.
That is a fantastic point. We should absolutely commit this and send this up to GitHub. What do we got? We adjusted the data structures JS. We created the hash table and we created the hash table spec. That looks right. Adding non-hashing hash table. It's a hash table that does no hashing. This looks perfect, right?
It's the hash slinging hasher or something.
We have no hashing. That is up on GitHub.
I realize I'm kind of old to be making SpongeBob references, but SpongeBob's amazing.
Are you kidding? Most of the people, I'm not sure I know a SpongeBob viewer who's younger than I am, Guy.
I do. I watched them with my kids, so good stuff. Good stuff.
Yeah, my kid is not old enough for SpongeBob yet.
No, not yet.
Yeah. That always drawing cards, you're totally right. Nobody is too old for pretty much anything, really.
I wasn't saying that I was too old for it, just to be clear. I was saying that I'm probably not the target demographic. So there's a lot of other people my age who don't get the SpongeBob references. That's all. I'm not too old for it.
You're too old for the draft.
I'm an outlier in my peer group in that regard.
Yeah. Okay, so we're committed now. Do we want to start making some changes?
Yeah, well, I was trying to think, do we want to write some tests to try and... I don't think the way we've structured this that it's very amenable to writing tests, honestly. Because if we look at the datastructure.js, we are deliberately exposing the linked list and the hash table. But in our hash table itself, I don't think we want to expose...
No, so the tests for this, because we're building a data structure, our tests are going to at some point, like, if you really wanted to test drive this, we would be very much testing the implementation of the underlying structure of it.
Yeah, and that always runs the risk of turning into an ugly mirror.
Exactly. So I think in this case, we're going to have to go, like, we want to stick with the user level tests of it, which is what we have.
Yeah.
Now, in theory, we could do a test where, like, we add 100 items to it and make sure it's okay, right? But we can add that at some point.
Yeah.
I think that's a confirmation that it works more than a driver of the creation of it.
I'm comfortable with this.
Okay, so let's try making a couple of changes. So first off, do we want to switch it to being why don't we change it? Why don't we first off create the buckets? But we'll do the buckets as properties. So instead of changing data to be an array yet, it's going to be the same thing it has, but the items in it are going to be the buckets. Yeah. So it's going to be an object that has the key, which is going to force us to do the first change, which is like when we return the value of the object instead of the key of the object. Does that make sense?
I didn't quite follow it there for a minute. Go ahead and start coding, and I'll track it.
Yep. So here's what I'm thinking. When we put it in here, we are instead of just putting it in like this, we're going to put it inside of its bucket.
Yeah.
Why did it jump? Oh, I'm still pinned to you. I was like, why did I suddenly lose where I was?
Let me pin to you.
Okay.
There we go.
So we're going to say key, value.
And actually, in JavaScript, with ES6, when the variable name and the key and the property name,
I don't have to specify it.
You don't have to specify it. So we could actually just one-line this, curly brace key, comma, value.
Yep. Which, funny enough, is the same thing I get to do in C#. It always disturbs me how similar ES6 and C# got.
Well, they're all these languages are sort of merging to this.
Yes, they're all becoming the same language.
Yeah.
Okay, so once we do this, the thing that's going to suddenly break is our fetch, which is supposed to get the value.
Yeah.
Needs to... so...
Well, let's run it and watch it fail.
Okay, you want to? Yeah, it'll fail here on fetch, I believe.
Oh.
NPM test.
Yeah, yep. That's kind of what we'd expect.
Yep, we got back an item that was Master Chief instead of getting Chief. And probably some other stuff failed as well, yes. So all the tests that were grabbing values came back wrong. Makes sense. So we want to see... I'm going to change this name from value to item.
Bucket.
Bucket? Sure, bucket. Bucket. And then this will be bucket.value. So we try to pull out the bucket. If the bucket is undefined, we return null. Otherwise, we return back its value, which does mean that we can store undefined now.
Yes, it does.
Hey, now they pass. Okay, good. So we are now storing buckets instead of just the value. So I think that was a good first step there.
Yeah.
So now do we want to get rid of this and replace it with just an array, and we won't be hashing, we'll be inserting by index maybe now?
By the index of what?
We know the size. I just mean like putting them in order, right? Like basically make this a like a vector object and like a list. And
I don't think that'll work. I mean, you're thinking about just putting them in, because we don't know the we won't know the indexes when we do the get.
You're thinking about the fact that we can't find it by key. I was gonna do horribleness, but yeah, we can.
Oh, you're just thinking walk it.
Yeah, exactly.
Yeah.
As the step.
If we're gonna do that, then let's use a linked list.
Yeah, there you go. Yeah, we could.
Well, I mean, because that's what our bucket turns into, is the linked list. Because that's
you're right. And then we just have to do multiples of those based on the hashing function.
Right, because right now we're creating a...
You're right. No, let's do that.
Yeah.
Yeah, we're going to store the linked list. No, you are 100% correct. All right, this refactor's on you. I did the last one.
Okay.
So give us a linked list.
Okay, so now it's slightly harder.
Oh, yeah.
Because we actually got to bring linked list in. So require, and it's not going to be at data structures. It's going to be...
Why don't you look at, go to the spec.
It's going to be right there. I did go to the spec, actually.
Oh, okay.
I think it did anyhow. Let linked list equal that. So we'll just require it directly. We'll bypass the root level object. Because
we're in the same one.
Because, yeah, exactly.
Yep.
And then...
we're in the library. We're in the module. That's the word.
New linked list.
Ooh, this is going to get some things kind of messy. For now, let's maintain our size as our own thing, even though we could use the linked list one, only because we know we're going to have more than one linked list.
Right. Let's see what the consequence of this is.
Of this? Yeah.
We got to save it.
Yep. Save and then run it.
Is it not saving?
It looked like it's saved.
Oh, I know why it works.
Because we overwrite it?
No, because linked list is an object and we had added properties to it.
Oh, yes, because we're just adding properties to a linked list object. Yes, we have an object of linked list and all we did was add properties. Yeah. JavaScript. You know, see, it's funny. The thing that you love about JavaScript sometimes, and especially in the past, when I'd explain to people like what the great thing about like HTML and JavaScript was, it just works. Like, you don't even, like, and it's not that you wanted it to. It's just that it really tries hard to just not fail. It's like, no, I did a thing. Not what you wanted me to do, but I didn't stop working. I just keep going. Yeah, exactly. Yeah, we did not want this to pass. We wanted that to fail. This didn't do what we wanted.
So let's see. We got
So let's change how we put them in there.
Yeah,
we're supposed to append.
Yes. So I was just looking at. I was trying to remember the methods we had added to the linked list. So we need to. So when we say put, we'll say this dot underscore data dot append.
Yep.
And then this, like that. That can go away. That should be different.
This should cause a failure now. Yeah.
Yeah.
There we go. Okay, expected null, because it can't find it now. So now when we make fetch work, what do we have to do to make fetch work? Fetch is now going to need to walk that
I want to do one thing here, actually. I want to rename this list. Are you okay with that? Nah, this is the wrong time.
No, yeah, don't touch that one, because this is going to be data eventually.
Yeah, it is. Well, it's going to be buckets.
Sure, it'll be buckets. Yeah, but it's not yet. But it'll be the lists plural.
It'll be the bucket list.
Yeah. It'll be something, but let's leave it as data because I think it's in flux.
If I had known when we started that we would end up with a bucket list, then the things we should add to it would be all the things we want to do before we die.
Wow, yes. Does our linked list do we have the ability to walk the linked list aside from just nexting through it?
No, that's we never came up with anything more sophisticated than that.
So Digital Drummer, the answer to that question is usually no. They have duplicate hashes, potentially, but the keys should be unique. Which we do allow, which maybe we should have a test that makes sure that we overwrite the one that is duplicate.
That's a good idea.
Which our initial implementation would handle correctly, but I don't know that this one will once we go down this path. Okay, well, either way, let's pull this because we're in the middle of a change.
Yeah.
And then we can add the test that confirms that.
Okay,
so we want to pull the correct bucket. So this is the code that is wrong. Is trying to pull the bucket. So
we need to do this data. We need a loop.
Yeah, I was thinking we need a loop, which I'm just going to while for now.
Yeah.
I wonder, will this do it? Oh, that's not bad. So we're going to say while this dot data. This is a linked list right now.
But we can call these empty on it.
What did we call the... What's our method on our linked list to pull data?
We got first item. We got first and last.
So it's first, and we're going to do first.next.
Yeah, and then that returns a node. And then if the node is a thing, we can then say .next. I think.
Yeah, so here's what I'm thinking. Let bucket...
Actually, we really didn't come up with an iterator for this guy.
No. You're just
going to be calling .next. Because .next is just the next node. It's not a function.
I guess I'll break when I found it. So yeah. Yeah, I'll just break when I found it.
Yeah.
First... question mark dot next.
Question mark dot doesn't work in JavaScript.
What? Yeah, doesn't it? I swear it does.
I don't think so. But first, so I think we need to go to first, and then we need to say if.
Yeah, this needs to be assigned to something.
Yeah, it needs to be assigned to bucket.
Yeah.
And then while bucket not null. Or while
no,
while
we'll
bucket
break.
Is not null and bucket dot whatever the value is to get the value.
This, isn't it this? Won't that walk the whole thing?
Yeah, I think it will. I'm just the first node has what's in it.
Yeah, Digital Drummer. We did break it. We're going to fix it.
Yeah. Well, it's while bucket's not null, because bucket.null means we're on our last... means we're at the end of the line. And bucket.value dot... no,
I was going to break us with the key.
Oh, okay.
So that we don't assign that. So I was just going to say...
that should walk the tree until we get
that walks the tree, and then I was just going to say if bucket is it dot value?
Yeah, it's got a next and a value. It's got a next, a previous, and a value.
Yeah, so bucket dot value dot key equals key.
Yeah.
Then break, because this is it. Yeah, thank you.
Yeah.
Then we want to... It's at that point that we have the right bucket, and we should return bucket value.
Right. And I think this is just return bucket.value.
No, because when we exit the loop as null, we... it'd be null. Are you sure we don't have null conditional?
90%? Let me Google it. Because if we do, then I'm missing out. And I don't want to miss out.
No,
but,
you might be right. Yep, you're right. How do they not have... I swear they have that. They don't have that?
It'd be nice. It'd be nice to have an Elvis operator.
Yeah, null conditionals are fantastic. Being able to do null propagation is just great. Yeah, I know TypeScript's obviously going to have it, but...
We could do this.
That is a good point. Just return directly from there, and then this is return null. And then we don't worry about it. That is a fantastic change. Good job, guy.
And then...
pair programming for the win. It's a value.value, isn't it? Yes.
Yes, it is.
Whoops. Our naming is gonna expected chief to be null.
Did our number of failing tests drop?
2 failing tests.
Has nothing to be retrieved.
When created has an item, cannot retrieve when that item is removed. When that item is removed, cannot remove it. So we got back Mario. So it did not. Remove didn't work.
Yeah, remove hasn't been changed yet.
And is this one also remove? Yeah. So remove doesn't work. So we still need remove.
Right. So, and how?
Yes, it does have the null coalescing operator. Absolutely, totally need that one. Let me pin the guy because I think you were about to do remove. I think.
Well, I was looking at linked lists to see how we'd implemented remove there, and so we do remove at index.
How do we know the index of the item that we're on?
We don't.
What were we smoking?
Pop-Tarts.
Okay, that might be true. That might be true. They were probably Pop-Tarts, like...
They were in the toaster a little too long.
Yeah.
You know, smoke detector went off.
Yeah, that makes sense. That makes sense. I would probably smoke Pop-Tarts.
Yes. So I guess the way we have to do this is walk it to find the index.
We might need to adjust our linked list. I know we weren't planning on working on the linked list, but we might need to work on the linked list.
Well, and remove at was the last thing we did.
Why don't we... So, yeah, instead of making a remove at, let's make a remove.
We got to remove first and remove last.
Which would cover our case right now, but we don't want to do that.
Yeah.
Why don't we do remove node?
And then pass it the node?
And give it the node.
Yeah, so we might be able to accomplish this as a refactor in remove at. Because remove node is kind of what we're doing here.
Yes. But what I was thinking is if we make a quick little we make a small test in linked list.
Yeah.
We just make a small one that is a remove. I think that we can have those two both do the same code. So like only one thing that actually does the removal and it does it for both is kind of what I'm thinking.
Yeah. Okay. So hang on, let me stop and think for a minute. Yeah, we will still need this. I was thinking maybe we could get away with not needing this, but we'll always need to remove things from a list.
Yes.
Okay.
And by specific one, not even like Because removing by index is great for our testing, but it's not our use case, which this is a better way of driving our use case.
Yeah, I'm looking at our linked list tests here, and I'm like, okay, I want to collapse some of this stuff because the file's just so long. When a third item is added, when we have a nicely populated list, when we remove an item from the end. I think I'm just going to say context or just describe remove, I guess.
Sure. Yeah.
For whatever reason, oh wait, I can collapse these. Okay, here we go. This isn't. No one's seeing this, but it helps me browse the code. I don't know. Actually, maybe you are seeing it. When we remove an item from the beginning, middle, and end. Okay.
So for removing an item from the
remove node, remote node.
Yeah, remote node, exactly. We want to remote a node. Make it so remote that it's not even there anymore.
Okay. And then we need to let's look at one of our remove examples. When we remove an item from the end, from the beginning, from the middle.
Yeah, find from the middle. Yeah, there you go.
Why do we have the removing an item from the beginning and end in there twice?
They're probably different levels of the context, so there's different numbers of items. Because one of them is probably supposed to be removing the last one or something like that.
Yeah, I think we may have just not had a good test name. It was towards the end of the stream. It was towards the end of the stream. So okay. So come on, collapse. There we go. We want to remove node. So we've got a well-populated list, and we want to say subject.get at.
Exactly. Yep. You got it.
Get one from the middle. We'll get number 2. So let node equal that.
Okay. Yep.
Remove node. Right?
Yep. I think that looks good.
Except that I totally did it in the wrong place.
Yep, you totally did.
And then I didn't copy it.
So node's going to be that. Copy. Put that code back. And put it down here. Yes.
There you go.
Yep, nicely done. Nicely done.
There we go. And let's see, it has a smaller size and it no longer has that item.
Yep, that looks good to me.
Has a smaller size.
And which ID did we remove before? We removed it 4 before, so it's a different item. So which item did we just remove? Let's take a look at the base list.
So we were using this one here.
Which one
we removed here. So we removed it 2. And so I did get it 2. Size should be 4. And the next value should not be gnomes.
Okay, so it's definitely gnomes. Let me unpin from you and confirm that list. So 0, 1, 2. Yep, gnomes was number 2. So, okay.
And we're just walking the tree here, but we could probably subject that.
We could do that as a get at.
To that value to not equal gnomes.
Yep. Let me get rid of the spaces that we left here.
Thank you. And so let's run the tests. There we go. Okay.
3 failing. It is cannot retreat. So that was Mario, Chief, and remove node is not a function. Okay, that looks good.
Okay,
so let's create remove node.
Okay, I'm gonna X that one. And let's go to the hash table spec. And which one is the one that's failing there?
Hash table spec? It's all the ones that were based on a removal.
Okay. I'm going to go ahead and describe hash table.
Exit that one, hang on. And then when another item is added to the hash,
here we go.
When that item is removed, and then when an item is removed, exits. Now those should be ignored.
Undo all those. Undo all those.
You don't want them ignored?
No, you can do it at the describe level at the top.
Oh, okay.
So if you go all the way to the top of hash table spec, you'll see I already put an X up there on X describe, or I thought I had. But you can put it right there.
Go ahead and just put it there.
Okay.
So that'll ignore the whole hash table tests for now.
Yeah, it should. Let's run it and see that it does. Yeah.
One failing test. So yeah, that ignores all of them. That's fine then. Let's have a look at linked list again then. So we made a remove. We need a remove node.
Yeah.
Remove node. Node. So we need. And I have a feeling
all the code for this is at remove at. In fact, it's probably everything after line 64.
Node to remove. You do this then.
Got an extra curly brace there.
I see that. Alright, so then this is just... do I need to this dot remove node?
Yes, you do.
Okay.
Which is one of the most annoying things about JavaScript classes.
Oh, did you put in the this, or did it automatically do that for me?
I'm not sure.
Okay. Well, let's go ahead and try this now. And see what happens. Hey, tests are passing now. So we have a remove node.
So if we go to the linked list spec, we can unpen the no longer has that item.
Correct. Let me...
I just did it.
Attach to you. Yep. I just wanted to attach to you so
okay.
We could see what you're doing. All right. So now we should have a... did that not save? Did you remove the X from the describe at the top? Hash table spec? Nope.
Oh, I haven't from hash table spec yet. I was doing it from linked list spec.
Oh, yeah, the linked list one is passing now. So now we're back to this one.
We had one of them X'd out.
Oh, did we? Oh,
yeah,
okay.
It no longer has that item. But it's...
I thought I saw everything that these were all passing.
I had pended it because we were focusing on the one test.
Yeah, okay.
But
those are all good now.
Did it all, so we're good.
Yeah, it's only the hash table ones now. So let's bring them back.
Yeah.
So now we should be at the point where we got to make sure the remove actually removes the node.
Yes.
All right. So these tests that are failing are the ones based on this. So expected Chief and Mario to be null, and they were not. And that's at the 2 remove points. Okay?
Yeah.
When another item is added, and then when that item is removed, you can still retrieve it. So this one is failing, and this one is failing. So we're expecting when you call remove, it actually removes. So remove. What you doing, remove? So in this, we need to find it. So why don't we call fetch on the key and then call remove node?
Yeah.
That seems like the logical way of doing it. So we'll say let node bucket. Right? Is that right?
Yep.
What do we do once we have it?
Be this to underscore data dot remove node bucket dot value. Or no.
Problem is we need to know which spawn it's
bucket.
in. So once we're calculating the hash key, I think we'll be better off.
Yeah.
Because we don't have that yet. So this has remove node. And then is it just bucket then?
Okay, so that
fetch
won't work
got us
because,
the wrong thing.
Yeah, because fetch is returning the value within the.
Correct. So we need fetch to call something else.
Right. So we need a helper function called, let's say, find, maybe.
Find.
And fetch and remove both. We'll call that.
Yep. That works. So we'll change this to be find. Find the key, and then this is the one that gets us back the thing, but without the value. So that means that we can't do it the shortcut way that we did of just returning back the value one.
Well, we just copy this block here.
Yeah.
And that becomes our find, but we return bucket.value instead of bucket.value.value. Or something like that. Actually, we return the bucket. The bucket is the node.
Yeah.
So this is find bucket.
Find bucket.
That feels like a better name.
Okay.
It feels like a name we'll use later.
Find bucket. All right. So, well, you know what? Do I need this? I need this. While bucket equal null,
we want to return the bucket.
Return the whole bucket.
Because the bucket is the node.
Otherwise, we return null.
Yeah.
I thought the bucket's the node? How did we put it in here?
By appending data. And so that creates a node with the data in it. That data is called the value of the bucket. I guess technically these aren't buckets, these are nodes.
Yeah, this is a node, not a bucket. So this is find node. Because the value of the node is the bucket.
Right.
So this finds a node.
Right. And then fetch just calls find node with the key and then returns what it gets .value.value.
Yes, so this just calls this .find node with a key. And this calls this let node equal this. And then return node. What's node going to equal? If node is null, then we return back null. Otherwise, we're going to do node dot value dot value.
Yeah, because we want the node value, which is the bucket.
Yeah, that gets you the bucket. That gets you the value of it.
Yeah, right.
Okay.
It actually might be clearer if we create an intermediate. Maybe not, because node could be null.
We'll leave it like this for now.
Yeah.
It's fine. So find node. Node is the first one. We find that, we return the node. So when this one calls find node, passing in the key, this gets back a node, not a bucket.
Right.
And we say remove node.
Right.
And that suddenly makes sense. We decrement the size by 1, and we're good.
Yes.
Okay, let's run our tests and see if that worked.
Hot damn.
Nice. It's always cool when you see. That's the funny thing is, like, we made a whole bunch of changes, and it's like when people are always like, "What's the point of TDD in this? It takes you forever to get that." It's like, yeah, but if I messed up any of that logic somewhere, there could be an insidious little thing that you don't spot for like 6 months. But that looks good.
Yeah. This feels like it's commit time again.
Yeah, it's a good commit time. I agree.
And then we had identified a test that we forgot that we needed for hash table. What was it? This is why we're supposed to write things down.
I mean, I don't know whose fault it is, but clearly it's the responsibility of the older pair programmer to make sure that you note things down.
So the test that we needed to add is that it overwrites the values correctly. So
yeah, you're right. That we uniqueness of keys. Yep, unique keys. You're right.
So we need to in here somewhere.
What did we do here? What did we just do? What does this commit represent? I should diff. I should see what this is.
Yeah.
I don't have changes. You lie. Why am I looking at it like this? This was foolish.
We made a lot of changes.
We made a bunch of changes.
Since I'm half inclined to say make the commit message. This is our second commit.
Okay, so what do we do? So linked lists removed by nodes. So that actually, you know what? This is entirely new functionality that is just related to the linked list. So I'm going to leave out the hash table and do 2 commits with this, and just do the linked list commit.
I'm good with that.
Yeah. So add remove node function to linked list. Commit that, and then this other one. What did we do here? So this is
yeah, I can't see any of your commits, so I'm just I'm gonna read chat.
Yeah, sure, you could read chat. So in this is where we started switching from the object to having a linked list as our underlying data structure. I'm not sure this is commit ready. This feels very intermediary.
Yeah, you may be right. The reason I felt it was commit ready was because
you don't want to lose it?
Yeah, well, because we're kind of at a high five moment.
Yeah, sure. Yeah, that's fine.
That sort of drives me to say I mean, in theory, we should be committing after every...
In that case, I'm going to give us a whip commit
test
on this, and say moving from object to linked list. What is this? Is the underlying data structure?
Yeah.
Okay. And I put whip at the beginning of it, WIP, which is the way that I tell myself this is an incomplete commit. So don't, if you need to go in the past, don't ever grab that one. Like, that's saved as a stage between working stages. Because it does function, but not correctly, because we know of a bug right now. And the bug we know about is uniqueness. All right, so
there's a comment in chat about that frozen meal I found the other day. You're referring to the steakums, are you?
Oh, yeah, the steakums, yeah.
I took the leftover steakums, mixed them with rice and salsa con queso, and had that for lunch today. So,
yeah.
I thought it was amazing, but my wife's going to make me sleep in another bed tonight. So we're going to go ahead and... What are we doing next?
We need to make sure that our keys are unique.
Right.
So...
Okay. I can write that test.
Yeah, why don't we go to the... If you want to write it, I'll pin to you. I was thinking go to where we create the first item. We'll do this in the simplest point. So if you go to the first item added, try adding a different master something. Is there another master something in... I
was going to go with Master Blaster.
Sure, really it's video game so we're going to do video game references instead of video game characters.
Yeah. Well, yeah. When we overwrite a value...
Yep, that works.
When we reuse a key, if we're going to do that, then why don't we... like that.
Yeah, okay, that's fine. Yeah.
When we reuse a key, we'll pass in master. Anyone in chat got an idea for an alternate master?
Hang on.
I mean, Master Blaster is fun to say, but
It is, but there might be another.
are you Googling it right now?
Yeah, why not? I've only got one master as the first name of male characters in video games category on Wikipedia.
Blaster it is.
Blaster, yep.
Master
Master Sword, actually. I like that. Master Sword, there you go.
Okay.
Thank you, Always Drawing Cards. That was
When
perfect.
use key. I'm gonna.
Whoa, hang on. A bunch of those, I don't think. So, still has size of 1. I think is a great one.
Yeah, I think the is no longer empty isn't that useful.
Correct. I don't think that's useful.
It has the new value.
Yep. So that'll be sword.
Yeah, and then I probably should do that.
Sure, yeah, we can check size of 1, because that's going to fail immediately. Yeah, expected 2 to equal 1. So, yeah, that is failing for the reason we expect. I'm going to unpin from you and make that pass, I guess. Yes, you are helping. Alright, so we did a fetch of a value, but it's the put that we want to have replace this, which means we need to see if there is an existing record. Right?
Yes.
So I'm thinking find node.
Again, yeah.
Find node at the key. We're going to say let node equal this. And then if node is null,
then we just do what we're doing.
Then we do this code that we have here. Yep.
Yeah, I was going to correct your C-sharpism.
Yeah, I know. I will always be C-sharping the code unintentionally.
Yeah, it's deeply ingrained habit. I forgive you.
What do you guys do here? This? Node.value. This is the node.
Node.value equals value.
Yeah. That line is great right there. Oh man.
I feel like I'm doing Java.
Have a good one, Katrina. Thanks for hanging out.
Yeah, thanks. Yeah, I feel like I just said object.object equals new to object, or object equals new object. Yeah.
Yeah, that's just a naming problem on ours. You know what I technically should have done?
There we go.
Okay, see, I asked if that was how you guys did that, but I don't know. All right, get rid of our X. I made them both pass instead of just messing with the size, because I could have been like, if the node's already there, subtract 1 from the size. You know, that'd be the super troll, and then the major problem would come up when this test still passed also. And you'd be like, because it was the first one of the 2 or something, you know, because I prepended it instead of appending it, and yeah. All right, so that passes. Okay, so we now check to see if the value is there. So let's hash. We got to get to we got to switch this to an array, right?
Yeah. So
which actually, why don't we commit this one?
Yeah.
Also, because this one is the one that fixes our keys.
Yes.
So fix the make keys unique again. Right? I think that's a valid description of what we did.
Yeah.
Okay. All right.
Okay, so
Also, I'm mildly insulted that Katrina claims she didn't know my name. She called us both guys. There's only one guy here.
Yeah, that's true. Yeah. There's a Guy and a Brendan.
Exactly.
Okay, so so we need to create an array of linked lists. And I think I just want to hard code the size of the array right now.
Yep, and I should pin to you.
Okay. And so this dot I'm trying to think how to do this.
That could just be an array right there.
Well, no, it will be, but we need to make sure it has the right length and everything. Because arrays in JavaScript are a little goofy, and there's a trick I've been using. I'm going to cheat to pre-fill these arrays, because there's an array.fill.
Yeah,
so you can say
like
new. You can say new array of size. Let's make it a size 128. Does that sound good? You want smaller, bigger?
Yep, that's fine.
Okay.
That seems huge, but yeah.
But now we need to fill it with something, because it won't be filled with what we think it's going to be filled with.
Yep.
And I think what I'm not positive about is if I do what I just did here, is that going to create one new linked list and then create them over and over again?
Is it going to? You mean is that going to make 128 references to the same linked list?
I think it does. And so, because I've had to do this weird trick where I would fill it with undefined, and then map that, and then ignore the value that comes in the map, and then call new linked list, because it's a weird JavaScript thing. Now I know this will work, but it's kind of ugly, and I don't want to do it if I don't have to.
Yeah.
Right.
Let me have a look, and
I don't know if but I've seen this goofy pattern before, and I'm
okay. Yeah. Note all elements in the array will be this exact value. So you are correct.
Okay.
So I'm looking at the Mozilla docs for this, and since it says this exact value, I'm betting that means that instance of the value.
So I don't actually need to pass in undefined. I can just call fill.
I'm sorry, what?
I don't actually need to pass in undefined. If you don't pass an argument, it is undefined.
Oh, yeah.
So, but this will work. This creates us an array of 128 unique linked lists. Okay. That is going to do a thing that we don't like. If we run this, it's going to probably fail in lots of interesting and weird ways.
Oh, yeah. Yeah, absolutely is. Because .first is not a function all of a sudden, because we're not able to even go in and right. access anything in there.
So
because we need to access the array now.
Right. So
we need to hash the key.
Let's look at put. So let's bring in murmur hash.
Yeah, let's bring in the hashing right now, because that's how we're going to determine which row we should be looking, which index in the array we need.
This should probably be const. Actually, this should probably be const too.
Yes.
And then to use murmur hash, we call this is how it works. So you say murmur.
Yay for docs.
.v3. Yep, I'm looking up at it. And then our key, and then we need a random seed.
That should be a const at the top of this file, right?
Yep, that's what it could be a const, or we could just generate a random one each time.
Sure, but at the beginning of this file, we need to create a thing.
Yeah, we'll say const murmur seed equals math dot random. Actually, I've got be math.floor times math.random times math.max
Do we need? Does it matter what the seed is?
As long as it's the same.
Yeah, you just need a floor if you want to do arrange, and if you're okay with it being, this will still allow 0.
That'll be fine.
Okay.
So
that's what I was wondering. Like, I don't know what the actual restriction is that we have to work with. So as long as 0 is okay, we can do that.
Yeah, I think it's okay. I mean, you don't actually have to pass a seed into it. It will pick one at random, I think. I'm not sure what the library does. I want to be explicit.
Okay, that's fine.
We'll do that, and we'll just get a number from 0 to max safe integer.
And I'm assuming that, I'm pretty sure that JavaScript's random, just like C#, if you don't specify a seed for your randoming, does a time-based one, so it's at least relatively... it's not going to be the same seed every time, so you're not going to get the same hash every time we call it, basically.
It'd be hash modulus the 128.
Yep.
Which means that we should probably make that a constant as well. Const. Array
size.
We could say this.data.size, but I'd rather do this.
Yeah, I almost want to say capacity.
Capacity is a great word.
Yeah.
Capacity. That can go there. That gives us an index, and then we can say this underscore data index equals the thing we're going to mess with.
Yeah, so instead of calling this .data.append, we're going to do so cut this and put it like here.
Yeah, I was going to go ahead and assign it to a variable just to make it a little clearer so we can think about it better.
Sure.
And this, so let list equal that. That'll get us our specific list.
Yep.
And then that's going to be list. No. This.find node is going to take.
What? No, find node's on the. Oh, do we have our own find node? Yeah, we do. Yeah, we're gonna have to adjust that one. So it's gonna take the key still. But why don't we? So what does our find node do in the hash table find node?
In the hash table find node? Oh, I mean, what should this do?
Yeah. Shouldn't we just be using the lists find node?
List doesn't have a find node. It has. Does it? Does list have a find node?
Is that not what we put on there?
We got remove node, remove at, get at. We don't have a search.
Maybe we should put it on there.
Well, it doesn't make sense to do so because we can't get a node. The linked list shouldn't know about the keys that we have because it doesn't know what keys are.
True. Yeah, I guess if we're gonna do that, we'd have to do a function on it.
Well, if we called get node, we'd have to pass the node to get, but then we'd already have it.
Yes, exactly. Yep. No, you're right. It's that, or we'd basically have to be doing a
strategy pattern kind of thing, yeah.
Well, yeah, sort of. Yeah, I was thinking like the way like array filtering works.
Right.
Like
that would actually be kind of elegant, but we're not here to do elegant things.
That wouldn't be the worst. It'd be interesting to show people how to do it. But yeah, you're right. We can go this route for now.
Yeah. Okay, where were we? I've lost my train of thought.
Sorry, what's someone said something in here? Hey, welcome. Greetings, Frank and friends. Thank you for the raid. Welcome, everyone. We are doing some JavaScript today. Some crazy JavaScript.
Yeah.
With guest guy Royse.
Array.from. Will that work? I haven't used array.from. Is that it may be because it's not a It could be experimental. I don't know. I just haven't looked at it, but we'll look into it in a bit because I think that's a great idea. But I like clean is better. I'm good with clean. Yeah. So we're in the hash table. I think fetch.
We are in the middle of a bit of refactoring right now as we're creating some data structures in JavaScript just for the fun of it, not like because we intend for people to use these, but it gives us a chance to dig in and see how these structures work and just to build them, and it's kind of interesting and fun. So right now, in a previous stream, we built a linked list in JavaScript, and we are leveraging that as the underlying data structure of the hash table that we started building today. So we are in the process of doing the hashing now, and the hashing is what's going to allow us to determine which index we should use in order to store our data. And the linked list we created is because a hash table does allow a collision in the storage, so it goes to that right spot, but then we use the linked list to, in case our hashing created a collision, we still need to be able to find the right value. So that's what we're building. So welcome, everyone. Okay, so
find node needs to take the list.
Yep, we're going to pass the list into it. I agree with that. So let's go to find node. We'll add the list, and then instead of calling this .data, we'll call the list. And then that gets us the node that we will iterate over until we find the right one, and then we'll return back either null or the value.
Right. And then if the node is null, then we say list.append.
Yep. If it's not null, we're going to append it, and if it is null, if it is null, we're going to append it. If it's not null, then we're going to set the value of that one. Yeah, that looks right to me.
Yes.
Okay. Do we want to try running these tests? Just see if we're at green or if something's messed up here.
Green, but we're probably better.
Yeah, exactly. We're probably not all the way there yet, but
list.first is not a function. And that's because we're calling find node from fetch as well.
Yes.
So I'm going to do the cardinal sin of copy pasta.
Yeah, that's fine for now. And then we're going to have to figure out where to get... We're going to have to make these... basically, we're going to have to wrap up the finding of the correct list based on the hash.
Yes.
Almost like a find list method might be a good way to go on that. They get you, which list are you supposed to look in?
Well, I think that's exactly the thing we need to do next.
Yes.
Now
let's see if it passes.
It didn't, but I'm not sure if it saved.
And to answer the question, we are using a tool that allows us to pair program like this in VS Code. It's called VS Live Share. So it's good stuff. Hey, JStuff, Leanwit, and anyone else that's in here. If I didn't mention your name, either way, welcome.
I can't see which test passed because the terminal on my side is kind of wonky.
Okay, let me scroll down and see what's going on.
Yours is much prettier as I'm looking at the stream. But it doesn't help me because
so we have 2 failing tests, and it is inside of...
I'm guessing it's called remove.
When that item is removed. So in remove, we're probably doing the same thing.
Okay, so let's do this one more time, and then we'll refactor out this
Yep. We'll put it in, then once the tests are passing, we'll refactor this out. So instead of data, we need to use list. Yep, pass that. And then list, yep.
This actually probably solves it.
I think that gets it. Yeah, there we go. Okay.
Okay,
excellent,
so
excellent.
A small refactor that might be worthwhile would be find node in list. Would be a better name.
Yeah. Find node in list.
Not a hard refactor, but it feels like a good rename.
Yeah. Let's run the test, make sure I didn't mess that up. Okay. Let's commit this.
Yeah, and then we need a find list. That's really what we need after that.
Okay, so this one is hashing to choose correct list.
Actually, adding the hashing here, based on what we've done so far, hasn't been too bad.
No, the hashing, but that's why we built it. That's why we did the steps of like, let's do the buckets first, because once we have those, and once we have the linked list, then the hashing just kind of. We thought about which. That's why we chose to go this way.
Yep.
All right, let's find list.
Yeah.
We're green, so I'm gonna start creating find list. Find list, since you did the last piece, based on a key.
It's gonna be
Copy pasta again.
Right, I know.
But this time we get to remove all the other ones that did it. Do I store the item in return list, or do I just return directly, you think?
I think we could return directly. That's fine.
Okay. I know some people that like going the other... And so in C#, one of the reasons why I sometimes go the other way is I'm like... They don't tell me when I'm debugging what the return value is. So, like, I can't breakpoint here and see what was returned unless I put it in an object, which is like, yeah, it's more efficient not to, but I wish your debugger worked better then.
Well, and we could probably also take line 45 and 46 and collapse that down to a single one.
Equals this dot find list.
And then find list and find node and list belong at the bottom.
So this, there should be a third instance of that code. Right
there in
here.
fetch.
And let me just make sure that this one, the put had it also. And how many times did we duplicate that?
3 times.
Just 3 of them.
Or
okay.
Twice. I mean,
Yep, they're all gone.
Copied it twice.
All right, so we are saved. Let's go ahead and run this. Did that?
Yeah.
So still works. Nice. Good. Excellent.
So I want to take these guys here. I want to take this guy here and just do a slight refactor.
Okay. Yep. Let me pin to you then, so we can watch you. Okay.
Are you pegged to me?
Yep. I'm watching.
Okay. So I think we can just do this.
Oh yeah, just one line that.
That just feels.
Yeah.
That's fairly straightforward to understand.
Yep. And the thing that I like about that is that we sort of hide that away in one spot, because I don't want, even though it's only 2 lines, I don't want that repeated everywhere.
I didn't either. I just being lazy. But I was figuring out what was the thing that needed refactored, even though I saw it coming. And then I put find list and find node and list at the bottom because they're private functions.
Not for Benny. You're totally right. That could absolutely be a const. Oh, and I'm glad you like the background music. There's information about the music down below.
Which const are we talking about on the list, or?
I mean, I think really they mean almost anywhere that we're.
Yeah, we could. I tend to use const. I've got enough Java in my background that I tend to want to use consts for things that are like strings and stuff like that. Like, so I'm using up here for the classes we bring in.
Oh yeah. So the weird part is I have one of the strangest backgrounds in programming because I used JavaScript in the 90s before doing like C++ or C# or Java or any of those. So I actually used JavaScript before those. So that's the really weird part. My habits are now C# ones, despite having gone through a lot of languages before C#. But that's my current, like, my muscle memory is currently on those. But it's like, it's weird.
Yeah, my first professional language the first language I got paid to write was actually COBOL. We should do that on stream sometime.
No, we shouldn't. No COBOL on stream. Kobold's on stream, but that's a totally different thing.
But the problem with COBOL is you wear out your caps lock key. So.
All right, we need to commit this again.
Yes, we do. I think it's done.
So this is.
I'm pretty happy with it, actually.
Oh yeah, no, I think it's good. We don't handle resizing, but let's do the test I was talking about. The one. Let's write the test where we actually insert in like 100 records.
Okay.
Let's do that. Something that we need to figure out if there's a way to check which we should actually be able to because we didn't hide the properties. Let's make a test that actually checks the internals to confirm that we really did use more than one list. Does that make sense? Like that our hashing actually did something? Let's do an overall test that does touch the implementation and just checks some values.
Yeah, it actually might be kind of cool to just write just to spit out the contents of it after we add like 100 items.
Yeah.
Just see how it's doing it.
Which
In fact,
maybe we make a
wanna...
debug, like a diagnostic method that does something like that and check that.
It kind of makes me want to put the capacity down low, like 32, just so that we can force that to happen.
Sure. I mean, you could set the capacity down to like 8 and make sure it happened.
We could. I have an idea.
Hang on a second. I'm committing. So don't do anything too crazy because people can't see it right now.
Okay. I was gonna suggest that we pass in the capacity as a constructor argument.
Removing code duplication. Okay. What you got for me?
Okay, so you're following me? Good.
Yep.
So I was thinking instead of having a constant for the capacity, we could instead have a capacity
in the constructor with a default value.
Right, and then say, this dot underscore capacity.
Yep, and store it
equals capacity, and then
which in the future will allow us to do craziness like increasing the size when we need to.
And then where was the other place we did that? That was down here. There we go.
Yep. And by that I mean increase the capacity. So when we have filled the collection, it was a good idea to make it bigger. Or once you have a certain number of collisions. So like when we append a new item on, we might do something like, check the size of that list. Did it get big? Okay, then we need to, like, once you have 5 items in the list or something like that, you've got too many or something.
I actually looked up before the stream what would be an appropriate trigger point for a rehashing of everything.
Yep.
And that sounded really good as a word in an English sentence. It didn't sound technical when I said it. Is that when the average number of items in your linked lists hits 5. Which is kind of interesting because then you have to then write code to walk your linked list and compute the average length of walk your array and compute the average length of all the linked lists. But it's also kind of
but we do. So
the question is, how often do I check that?
No. So what I was suggesting is if you check, so you don't actually. So first off, you wouldn't have to do that because you don't have to walk the linked list because we maintain that, and you don't have to walk the array to get that value either, because what you can do is store this dot average what is average something, right, is like, would be 0.00 or something like that, right? I mean, we don't have to actually write it that way because JavaScript, but the point being that then when you add a new one, you actually, so like if we add an item to an array, then each time when we're appending, we would add so we would add 1 divided by the capacity, right? And then that's the amount that you increased by.
That would be much more efficient.
Yes, exactly. And then when you remove the same bit. Now it's not quite perfect because you might need, so like when you trigger a rehash, I'd recommend you recalculate that. Because again, we're using floating point numbers, so it's gonna be terrible.
Yeah.
if we're adjusting it this way. But this might be enough to cover that. Like essentially how full are they? The fullness percent or something, like
yeah. Well, and in JavaScript, it's really easy to run into floating point number problems. You run into them if you try to use floating point doing the vending machine kata in JavaScript.
Yeah, of course.
And you run into it when you do 0.05 nickel plus 0. Plus dime plus quarter.
And that already is going to have a problem. Yeah.
And that's 0.39 repeating.
Yeah, but we don't. The thing is that we don't care about that, right?
I know, but
we're just looking for like a rough threshold for a rehash.
Right. I was highlighting that simply to say that to highlight how easy it is to get floating point weirdness JavaScript.
Yeah. But that's why I figure like.
Yeah, that would work, but we don't need to do that yet. So let's go ahead and I'm going to delete line 11 here. And let's write a test that puts a bunch of crap in this thing.
Yep, let's go make a test. It fills it up.
So when created, and then.
So let's do a context for it. That's I'm going to get rid of this just so we can see more of this.
Sorry, I'm typing. I don't know if you're following me or not.
I'm watching you. Yep, we're on you. I was just getting rid of some extra
clutter. A lot
clutter.
of things are added.
Sounds good to me.
We could say un monton.
So for before each. Yep. Stupid this. Unnecessary this.
Yeah. Extraneous this. Okay, so we can say, I guess, for let I equal 0, I less than
500.
Yeah, 500, I plus plus. Although
that should way overfill this thing.
Yeah. Subject dot put, and then for key, we'll say key. Well, let's be fancy.
I was actually going to suggest we do that.
Oh, yeah.
Yep. Interpolate that string.
And then
do the same thing for the value, I would.
Yeah.
Yep. That's what I was thinking. And then just do that. Yep.
Just to make it. Yeah.
Yeah, so Stali, I agree. I also like the syntax of arrow functions as well. And that's one of the things I really like, the fact that so many languages added in the arrow function syntax for their lambdas and stuff.
Yeah. Unfortunately, we're using it all over the place here on like 1.16, and Mocha, which is our testing framework, messes with the value of this itself, and so we can't use arrow functions there. Otherwise, unpredictable things can happen.
Yep, Guy gave me the Mocha warning when we started this one. That is like, yeah, you can't get away with that. And it's like, because
I so want to do it, right?
Yeah. This in JavaScript might be almost everyone's nemesis.
This will work.
That actually should just straight up work. Because for that, we're just adding, we're just plussing a whole bunch of times.
Yeah, I'm just mostly throwing it in there to make sure that my to test this the before.
Yeah, that makes sure it actually didn't break when even running it. Yep.
Yeah. And that still works.
Okay.
Okay, what should we assert here? What should we look at? Do we want to just spit some stuff out?
Sure. We can try to pull something. Why don't we try pulling just a random key? Like, why don't we try pulling key, like, 400 or something?
Okay. Or do we just want to look at the inner structure to see that it's actually doing what we want?
We can. Let's do this one, and then we'll also look at the inner structure.
Oh, we forgot one other thing.
What's that?
What's our size right now is defaulting to 128. That guarantees that we're going to have some, but it doesn't guarantee they'll all be in the same place.
Yeah, we don't know where the duplication's going to be.
Right. If we made it really small.
All right, we'll make it 8.
Oh, well, but in order to do that, we have to say subject equals.
Oh, yeah, we'd have to new subject here.
Yeah.
You know what? Hang on. No, we don't. Go to the original creation.
We can just do it here?
Just do it at the first one. Yeah, let me pin to you.
Do you like 16?
When we create our new hash table, yeah, make it 16. There you go. Because 16 was big enough for all the other cases.
Yeah,
In
we only
fact,
added
it's
3 things
ridiculous in the
next
other
to it.
ones to start it at 128 when we're storing 2 items.
Yeah. Okay.
I think I'm anchored to you. Where are you? Yeah, hash table 16. There we go. Okay.
Okay.
So let's check
Run
it.
that again.
Oh, you're just gonna run it again? Yeah.
Yeah, I just want to make sure 16 doesn't break it. Okay, so we need to say it's most likely.
What? No. Let's just grab one in the middle.
Yeah.
Although, actually, wait a minute. I had a.
There is no guarantee.
Wait. Hang on. Wait. I have a crazy. Can retrieve every value.
Okay.
I'm gonna put the same loop in.
Okay.
I need to unpin from you because that got bad when you pulled me away.
There
yes,
we go.
I think this is crazy, but I think it'll just work.
It's crazy enough it just might work.
Exactly. We fetch that key. Wait,
Yeah.
Fetch the key. I'm going to need to write the expect on here anyway.
Yeah.
To...
I'll go ahead and I'll type up the expect for you.
Thank you. Yep, put that on the beginning, and then I need an extra paren here. To equal that value. Is that it? Yeah, get the spacing right. Thank you.
Yeah, that would test all of them.
That will literally grab... So we're guaranteed to get the duplicate. Even if it shoved them all in one, it should guarantee that there was a duplicate somewhere in that set. We walked a list here. We walked a lot of lists here, guaranteed.
Is it working?
I don't know. Let's find out. Did you run it?
No, I was waiting for you to do it.
58, yep. That's passing. So we can retrieve them all. Whew.
Gotta catch them all.
That's crazy.
Man, the stream just went all blurry on my side.
I'm not sure. Guy mentioned it, but yeah, we can take a look. If someone thinks we can get away with using arrow functions, we can try it.
Well, I mean, if you go to Mocha's site, they explicitly say that we can't.
So maybe it's under a certain condition, so they tell you not to, just so you avoid that problem.
That's possible.
Okay, so we need to. So we want to make sure that it really did do the data structuring. It really did the. It uses all of the lists. I'm going to say underlying lists.
Yeah.
Which this is the test that... So this will be our one test that really does look at the internals, because we've been trying to avoid writing tests that do that. So this test is more brittle because it is going to have understanding of that underlying data structure.
Yes.
Robin, that might be correct. Which I don't think we're using this at all, so we might be able to get away with it. So expect subject dot data.
Did we call it data?
Yeah, but I'm thinking we want to grab capacity first. So why don't we, since we want to make sure that it's using all of them, why don't we do a for loop and say for let I equals 0, while I is less than subject dot capacity I plus plus.
Okay. It is an underlying array. We could probably...
You mean just for each it?
Yeah, we could for each it.
Yeah, we can for each that if you want. Instead of doing it this way.
Yeah.
So it'd be subject dot... Oh, that's funny. It's going to do an arrow function here. which we can totally do.
Oh, yeah.
Subject dot underscore data for each list. We want to say expect the list dot size.
There is a list dot get size.
It's get size. You're right.
Or no, size is just a function, no get.
How do we say how do we say to be greater than?
I think you say to be dot greater dot than. I can look it up.
Greater than 0.
I think
We'll
you might.
that. Is that the right size function and everything? It'll tell us if I'm wrong, right?
Yeah.
If I messed up a name. Get size is not a function.
It's
all
size.
right, linked list.
Size.
What was it?
It's this.
Oh, okay, it is just size. See, I was right.
My bad.
Whoa. Every list has a size greater than 0, it says.
Let's do 2. Let's increment it until we make it fail.
20. They can't all be more than 20, right?
They cannot.
There you go. Expected 20. Oh my god, it broke on 20. The exact value.
Oh, did it really?
Yes, expected 20 to be above 20. That is hilarious.
Well, it's the first one that hit that matched that, probably.
Huh.
Okay. I think it might be kind of fun to say console.log. I just kind of want to see it.
But
list.
won't that log it every single time?
Well, yeah, but that's your console, not mine.
Thanks, guy. Thanks, buddy. That's gonna be great.
So if we log out the list, that's an array list, so that actually isn't going to look very good. It's going to just be object.
Why don't we do .size on them?
Okay.
We'll just look at the sizes, because it should be a bunch of varying numbers.
Yeah, and let's do we have? No, we don't have the names. That's fine. Yeah, let's see what it does.
I apologize to whoever Nightbot just hit. You probably didn't actually put in a link, because it gets confused by code sometimes, because we have dots in there. Okay, so there's our size of 42, 33, 30, 34, 41. That's actually... And the cool thing is, it's fairly nicely distributed.
Yeah, it is. Well, and we made this thing a size of 16, so we're just spitting out 16 lists.
Is that 16 lists? That doesn't look like 16.
No, it doesn't. Now it's starting to, maybe.
I like how the terminal didn't actually display right.
Yeah, it looks like what mine does all the time, but better.
Yeah.
It might be kind of fun to
4, 5, 6, 7. No, it's 16. It's 16. We're just bad at we're humans. We're not good at estimating how many things were in a list of numbers.
Yeah. Let's do list first.
Oh yeah, we could do the first value in any given one. So it's hang on. Let me look at this. Since we did this 2 weeks ago, yeah. First is a function that gets us the first node, and then you should be able to do first.value on that.
Actually, we should be able to print that out as is because.
Oh yeah, and then it'll have the key too.
Yeah, it'll just show us the object because the node itself is just an object.
Yeah. Let's run this and have a look.
I'm waiting for it to show up on stream.
Cool. Yeah, those are big and nasty.
Oh yeah, because it's looping through them.
But look, they've got like key 5 value 50, key 60 value 600 because it shows the next and the previous on them. So because we grabbed the The first one in each set, it's gonna have the next object each time also.
Cool.
And I love how I didn't know it did this, but I love that it's telling us circular on that, because it's letting us know this went back to the object that we already had.
Yeah.
Because we're doing a linked list, so it's like, hey buddy, I already did that one. That's actually really nice. And you can see that they're just distributed in here. So yeah. So look, 0 came in as the first one at whatever this one was that ended up having 30 items in it. And there didn't get to be a second one until the 18th item, which sounds about like, that seems pretty accurate. Like when you look at the, like if it's going to distribute kind of evenly as it goes through, it's going to be very uncommon for the numbers to be too close. So this is actually probably as close as they usually get.
Yeah.
So a 1 and a 4. 5 and 60. Whoa, that's a big gap. But yeah, no, that's interesting. So 3 and 6, that's another close one. But yeah, that's neat. It really did what we expected. That's actually really awesome. I like that.
I feel pretty good about this.
Yeah, let's not have this console log in here when I commit this.
Yeah.
And actually, I kind of want to make this greater than 0 again, just to make sure that there is 1 in there.
Although technically, that test could fail.
This test can fail, yes.
Yeah.
Yep. This test can actually fail hilariously. But that's why I'm setting it to 0, because that makes it even less likely to fail.
Yeah, I mean, I feel pretty confident that we could run this hundreds of times and never see it.
Yes, exactly.
We should probably put a comment.
Stolly, this is this test framework is Mocha.
We should probably put a comment in the code to the effect that this test could fail because it's not guaranteed. This test is not guaranteed to pass, and we know that. Can fail.
Based on
math.
Yeah.
Just in case someone pulls this repo down later and says, "Oh, hey, I can copy this." Well, hey, you shouldn't be writing this in JavaScript. B, you probably shouldn't be writing hash tables on your own unless you have a really good reason.
Yes, exactly. We had a disclaimer at the beginning of this stream, which, by the way, all of my streams are recorded, and you can find them in the videos section here as well as on YouTube. But we mentioned at the beginning of this that you should not be doing these kinds of things for your production code. Don't go and rebuild the data structures, but this is a good way of getting an understanding of what is going on when you actually look at these. Now the funny thing, so we're doing these in JavaScript. I actually did a bunch of like underlying data structures work long time ago as examples for people in C#. Yeah. And you do the same types of things, leveraging like, well, I know it's going to pointer to this thing and create this stuff. Yeah. Like when you do linked lists and such. Okay, let's commit this. Commit this.
I think we're ready to wrap up, actually. I feel really good about what we got done today.
Yeah, same here. So this is, what did we do? We created the, what did we do? I actually want to look at the diff of this. Whoops, didn't mean to click that button. Okay, so this is adding in the capacity and testing that it's really using that capacity.
Yeah.
Okay, so handling this is configurable, not adjustable, because it doesn't automatically adjust. Static capacity and I
can actually look at the git diffs in Visual Studio Code. That's handy. I didn't know I could do that.
Oh yeah. It has built-in
I knew it had
stuff
that
with Git too. It's right over here.
I just didn't know it would work with the live share.
Yeah, it should work.
It does.
Yeah.
I'm just so used to being using.
You know
Git
what? Here.
inline.
So we could commit it over here. These are the stage changes. So this is configurable capacity. tests to confirm filling lists. Test to confirm filling. There you go. Look good?
Yeah.
I don't know if you get to see that through live share or not, but
No, I didn't. But I was just going to go on faith.
okay, cool. Yes, it's Litany. Guy does have an epic beard. Maybe do the runs and the tests and yes. So that is actually correct. You can reduce the odds of it failing by, in fact, running that test many times and making sure that it passed most of them, which reduces even further the likelihood of that failure. Although you can still have it fail sometimes, but you're right that doing so will illustrate to anyone that looks at that test that there is a chance of it failing.
We could make it not fail guaranteed by hard coding our math.random call to a hard coded seed.
That's true. If we did make the seed configurable.
Yeah, then if it successfully passed, we know that it would successfully pass every time.
Yep.
Which is not exactly the same thing as making it pass every time.
I would rather it be able to fail.
I think I would too.
Because you want to make sure that it works with these random values,
yeah.
Which this does.
The hash table, one thing I'm not sure I like is that we create our random seed outside of the class, which means the seed is being randomized not when we create a new hash table, but when we create a require the hash table thing. And I don't think that's terrible.
We could do that in the constructor, though.
Yeah, it's actually not a bad idea. Yeah, let's do that. That's a quick refactor. Do you want to do it, or do you want me to do it?
Yeah, no, let's go for it.
Okay. Shall I?
Yeah, continue on.
Okay.
Because we were just moving that in here.
This dot underscore seed equals this value.
Yep. And get rid of that.
And then we only use this at one place.
It's
here
in that one method, which I'll pin to you. Yep, there it is.
Okay, and this dot underscore seed. And yeah, that's it. Let's run the tests. I don't think I have control of your console anymore.
How did you lose the console?
I don't know.
Tests still pass.
Everything's still good. And what we could do in that case, we could even do like seed equals, we could say seed.
Yeah, so
equals 0 maybe.
Yeah.
Or seed, we'll do it over here, equals 0. And then we could say seed equals seed or that. So if someone doesn't pass the seed in, because 0 is falsy.
Yeah, but you could do this instead and...
That's safer.
And do this.
Okay, let's try that.
Right?
Yeah. Is the double question mark working? Yeah, that doesn't work in JavaScript.
What? I swear that works in JavaScript.
It might in newer versions, maybe the version of
So we're in an old version of JavaScript, maybe.
Well, or that could be we might add this in this version, but we haven't decided yet sort of thing.
Okay, there we go.
Incidentally, that or thing would
if
work.
We're going to do that, so if we're going to make it so 0... Well, I guess then the only way... So then someone can't give us 0. So that should be a null coalescing operator, it's Litany.
You could do this. Rather than doing the or operator, you can say seed, null, then...
Yeah.
colon seed. Except probably not. This way would be not equally. I can't hit exclamation point. If the seed is not equal to null.
So people in the stream that are wondering, this is how it is supposed to work in JavaScript. Here I am on the Mozilla documentation.
What's it say for support for it?
Yeah, let me look. That'll be on the bottom.
Well,
Node.js, no.
Use it.
So, if you're in Chrome, Edge, Firefox, Chrome for Android, you get it.
What about Safari for iOS? No.
Safari on iOS, man.
Yeah, that's why I didn't know about it.
Yep, there you go.
So yeah, you could do something like that. But I actually think it's unlikely anyone's going to want to pass in their own seed.
Yeah, just I would agree.
I mean, I was just screwing around, right?
Yep. No, I like it. I like it this way. Let's make sure that we didn't screw around too much and break things. So we're going to run the test again. I know. As Cadmus says, hooray for inconsistent browser support. We're right back where we were in the late 90s with, yeah, you've got JavaScript, but good luck getting whatever you wrote to work everywhere.
Well, we can say if browser equals, and then we'll be fine, right?
Oh yeah, we're totally gonna start. Yeah, we're gonna bring that back. That's gonna be great, guy. Yes, we could do that directly in there, Robin. That's true.
That's actually an interesting idea. I both kind of like and dislike that at the same time.
Yep.
Because I kind of like it because it creates the seed appropriately, and if you pass it in, it overrides it. But I don't like it because then it turns into...
into what you're about to write.
That highlighted bit of code then goes in the arguments. And it's like, okay. And that feels kind of ugly. But then I could write a function to wrap that up, and that might help that. And
Yes. If you if you put that in like a default seed function, but either way, I'm okay with it as written here.
Yeah.
This is fine. We don't need it as an argument even at all. Like, no one's gonna pass us a seed.
Yeah, but a capacity they might. They might say, no, I know that I'm going to shove a metric crap ton of data.
Yes, exactly. Which, to be honest, even this 500, I would go with a capacity certainly larger than 16.
Yeah.
16 is a terrible capacity for that. 128 wouldn't be the worst, but I wouldn't, like, if I knew I was putting in 500, I might go with more than a 500 capacity, saying the storage is not that expensive in order to make sure that I've got fewer collisions if fast access is what I want.
Right. That's actually kind of neat because then being able to adjust the capacity like that, even though it's static isn't great, does mean that you could optimize for that. You could say, no, I want the read time to be super fast in exchange for space.
Yes.
So I'm gonna trade off space complexity for performance complexity.
Yep. Exactly. So, which, in case people were wondering, because they've asked, like, why are you doing this? It's like, well, because it's kind of fun and you get to talk about and, go over the data structures. That is a good point, because, like, as developers, we can consider these kinds of things. And, for example, in C#, we can define the capacity of a collection that we create when we create it. So if you knew that you needed to start off with a larger size collection, you can choose that capacity to begin with, so that it doesn't have to do the growing trick, which it's common for those to grow at rapid paces. When you do exceed the size of a collection in most languages, they'll double it or some equivalent where it gets larger quickly.
Yeah. Cool. Well, I think we're done.
Cadmus, yes, we could do something to get browser support if we wanted, but we're running in Node also, which means that we're just going to rely on what the version of Node is that we're running. So I guess this technically could be wrapped up into a into a reusable chunk that we could send somewhere else and get browser support. But at the same time, because we supported such a minimal set, I think what we used here is gonna work almost anywhere already. We barely used arrow functions, let alone the null coalescing. What other questions did we have in here? Just sounds like we shouldn't use JS for complex math in browser. Yes, Desert Griffin, that is accurate.
Yes.
You probably shouldn't do complex math in browsers using JavaScript.
Yeah. Hashtag true story.
Yeah. Almost like that's not the use case for JavaScript.
Yeah.
In a browser, I should specify. You can do some of that, but yeah, JavaScript's not exactly a great math language.
Yeah, I was saying earlier in the stream about where if you add 0.5 or 0.05, 0.1, and 0.25. So if you add a nickel, a dime, and a quarter together, you'll get 0.39 cents.
Yes.
And and so the way you solve that, of course, is that you just use integers instead, and then that helps. But even in JavaScript, I don't think they're truly integers under the covers.
Probably not.
So, but then again, objects aren't hash-based in JavaScript under the covers either; they're array-based. So,
yes,
or no,
exactly.
arrays are hash-based. That's what it is. So there's all kinds of goofiness going on in JavaScript.
Yep.
I think next time we should do this again in 2 weeks.
Yeah, let's pencil that in and make sure it works for both of us. But yeah. Sometime in the future.
Yeah, I mean, I'm not planning on going anywhere.
Yep.
And I think in 2 weeks I'm free. But I was thinking we've done hash tables, we've done linked lists. Do we want to dive into probabilistic data structures, or do we want to do something like a set or something like that, or queues, or?
We could go. I would be fine with going either way on that one. If you think any of the other ones are going to need some of those other underlying data structures, we can go build other underlying data structures.
Yeah. Well, I know Bloom filter doesn't, because a Bloom filter just needs an array internally and some hash functions. So
yeah.
So we could do Bloom filter next, I suppose. That's fairly straightforward. I actually don't know that that'll take up a full 2-hour stream. Although I said that about linked list as well. So
yeah, you didn't think linked list was going to take a whole stream, and it took us a whole stream plus what we did today.
Right. And then hash table, I actually thought, well, this might take more than a stream, and then it didn't.
And the hash table was actually less. Yeah.
Yeah. So I guess what I'm saying is, what the hell do I know?
Apparently nothing.
So yeah, but we can try Bloom filters, and if we finish that, then we can pick another structure. I've got a couple other in my head, so
that's seriously not working. Well, I'm gonna have to go mess with my bot at some point.
Yeah, we can do heaps. Heaps could be fun. That's a good call.
Yeah, we could do. There's a lot of interesting stuff, and the fun thing is you can start doing you can do some fun algorithms with things as well. Like once you build the data structures, you can start doing some other weird stuff. Like we could go into searching algorithms. We've not done anything. We've not done heaps yet. So far, like, this is the second episode. We have done the linked list, which was the underlying structure of the hash table that we did today. We leveraged the array of JavaScript rather than writing our own array because, well, duh.
Yeah. I mean, if I was writing these in C, I also wouldn't create my own array. So. Cool.
Yeah.
Well, I guess I should. Well, I guess we need to wrap it up, don't we?
Yep, I was figuring we'd go ahead and do a little bit of wrap-up, which, for that, I want to mention to people, first off, don't duck away just yet, because I do want to tell you about a couple of things. So first off, we are going to try to continue this, plan on it being 2 weeks from now, but in case anything weird with schedules, might end up being 3 weeks from now or 4 weeks from now, who knows, we'll find out.
Yeah.
But regardless, we will make sure we keep you in the loop. If you do want to make sure that you are in the loop on that, the best way to do that is to make sure that you're following us on Twitter. I am at Brendonius, and Guy is at Guy Royse, and you can see our Twitter handles just below us. And links to that are down below the stream, but also we will post those links in the chat so you can find links to that stuff in places. Also, if you missed the beginning of this episode and you want to see how we got to this point, or you want to see the previous episode, check the video section here on Twitch, and you can find both the recording of this one is already there, so you could actually just start watching that. And the recording from our stream 2 weeks ago, you'll see in that as well. And if you want to chat with any of us outside the stream, the Discord link that Cadmus posted in chat or the link down below is a great way to talk with us or the rest of the DevChatter community, of which there's a whole bunch of people in there. Literally hundreds of developers are in there. It's not like... One of the things I like about it is that it's not like super active. I'm not constantly getting notifications about it, but every once in a while there's discussions about interesting stuff, programming related. So feel free to join that to chat with any of us. And Stoolpenner, I think it's like 500 people are in our Discord. Maybe it's 600. I don't remember exactly. What other stuff do I need to mention? Oh, and there are also YouTube archives of everything we've done here on the stream, so if you want to catch any of that, that's a great place to do that as well. I want to make sure that before I run the credits, that we also thank Guy for joining us.
Yeah, I appreciate it.
Yep, Guy, welcome. You are always welcome on this stream. The DevChatter community has been a fan of yours for a long time.
Well, I am in there too, so you can always. I don't check the Discord very often. But if you at me, I will see the message.
Yep, he is in our Discord, as am I, obviously. And so are like all of our mods and everything like that. And it's a very welcoming and friendly community. And we try to keep it that way. But let's go ahead and roll these credits.
Well, I did have one thing I wanted to announce, if you don't mind.
Oh, yeah, go for it. I don't know that I can kill my credits, but...
Well, we can talk over them, though, right?
Yeah, sounds good.
So I'm going to be... I'm going to start up my channel proper this coming Friday from 2 to 4 p.m. We're going to do a little pilot, little 4-week every Friday afternoon, 2 to 4 p.m. Eastern time. And I'm going to be writing a MUD. For those of you who don't know that, that's a multi-user dungeon using Redis's graph database and Node.js. So
that sounds awesome.
I think that'll be a lot of fun. We'll see how far we get, and in 4 weeks, and then we'll reassess if we want to keep doing it or not. But I'm going to try and start streaming every Friday. So
it sounds awesome. I too am a fan of MUDs. They are you're doing. It's just going to be a Node program that you'd run for that.
Yeah. So I'll set up a little Node server so that you could SSH into it or connect to it in some fashion. I haven't figured that out yet.
Nice.
But the interesting thing, I think the interesting part is I've been looking at graph databases, and Redis has a graph database that I'm using, so it's all in memory, so it's fast. So I'm like, you should be able to scale this really good. Is a graph database lends itself to the nature of like topography really well. Mm-hmm. So you can, each node becomes a room or a monster or treasure, and then you can define the relationships very cleanly with a graph database. So I think that'll be kind of a fun way to model that. I'm kind of thinking overly optimistically that technology's come a long way. Creating a text-based game that stores things this way should be easy. But I know that I'm going to get in there and be wrong.
But that a lot of times is the fun. You dive in and you're like, this didn't exactly work the way that I thought it would.
Yeah. If you want to join me on some of them, Brendan, that would be totally cool. That could be a lot of fun.
I would be willing to join you on those as a guest pair programmer if you like.
Yeah, I think that could be fun. Just getting in there and figuring out how the MUD needs to work. It's the getting into the multi-users where it starts getting complicated. That's easy to manage on something like Node because you do just have a single process, single thread. But just that behavior can still be very complex.
Yes.
So we'll see how that works.
Yep. I think it'll be a blast. I would love to join those streams. Let me know. And I would be glad to pair on that.
Yeah. I don't know how your Friday afternoons look, but
it depends on the Friday afternoon.
Okay. Cool.
For example, like yesterday would not have worked at all. Even if I'd been planning on it, it would not have happened.
Yeah.
Work got a little crazy. So, which I'm sure everyone is aware of. Occasionally, as programmers, we...
life happens.
Yes.
Work happens.
We suddenly become extremely busy for short periods of time.
Yeah.
Excellent. So question then to the people here. I was figuring, I figure we'll either raid or host over to someone else. Any preferences? I could go. I could send us either to gaming streams or programming streams. Where do people want to go?
So I actually got a question. Is
Yeah,
it
what's up?
NREND? I said your ECS mean Elastic Compute or the Elasticache service? Yeah, it can't do graph, so it only does the caching. So just to answer your question real quick.
Good job, Guy. Way to catch the last minute question. I don't see anybody jumping in with suggestions. I am not sure I've seen that stream, and I have a rule that I don't raid any streams that I have not actually myself watched. And can say.
Let me see if my buddy Loris is still streaming.
I'd be fine streaming some going over to a stream specifically that the guest watched.
Yeah, he's still doing it. He's coding up a Redis MPX multiplexer in Go.
We can head over that way,
and he could use some love. So
all right, we'll go towards that one.
Cool.
And I will switch us over to our outro screen and then raid. So stick around, everyone. Guy, type in the name in chat so I can copy paste it and I don't mess it up. There
you go.
Either way, if you didn't yet, be sure to hit the follow button. That's the best way to get notified when we go live on our next stream. And make sure that you're like following on Twitter and in the Discord, and that's the best way to, make sure that you're like here and not missing streams. And as soon as Guy has does your channel exist? Are you just streaming on this account?
This is which account? The
account you're using right now that you're logged into.
Yeah, that's
Guy
Royse.
Yeah. So click on Guy's name in chat, and you should be able to click a follow button on him there as well. So be sure to do that so you catch his Friday stream. And I'm going to toss us on the outro and raid us over in a minute. Have a good one, everyone. Bye.